So with that, I want to introduce our first speaker. She did her graduate work in David Agard's lab, and Kristin Krukenberg is now a postdoc in Tim Mitchison's lab in the Department of Systems Biology at Harvard Medical School. She's been the co-chair of the Postdoc Association of HMS, and also has co-organized a series called the Postdoc Forum, out of which the genesis for a symposium that we ran together in Boston came. The title of her talk is Perspectives from Students and Postdocs, Summary of the FOR Symposium.
Thank you, Jessica. Let me just quickly switch. So as Jessica mentioned, today I'll give you a bit of an idea of some of the perspectives from students and postdocs, and this came out of a symposium we held in Boston in October. So as many of you probably know or have seen, there's been a sort of rash of articles recently about some potential problems with the biomedical workforce. So issues having to do with the decreases in funding, the number of postdocs and graduate students, as Jessica mentioned. And there's been a lot of comments from prominent members of the community, as you can see from a few of the articles here. And if you'll notice at the bottom, these issues are now also starting to make it into the popular press. So there was a series on NPR about some of the funding issues and training issues that are currently going on in biomedical research. But one thing that we noticed that was sort of absent from all of this was a voice from the trainees themselves. So how do grad students and postdocs feel about the situation? And are there things they'd like to see changed or that they think should happen in the future? So a group of postdocs in Boston, there were probably about 20 of us from about 8 different institutions came together, and we decided that we really wanted to find a way to give graduate students and postdocs primarily a voice in the discussion. So to do this, we decided to organize the Future of Research Symposium. So this was a day-and-a-half event that happened in Boston, and it sort of had a dual purpose. So the idea behind this was both that we wanted to inform graduate students and postdocs about some of the issues, the sort of structure of the system, the way things work now, and what a lot of people were saying about problems with the system. So we wanted to have talks and panel discussions where we'd invite knowledgeable speakers who'd been very vocal about some of these issues. But we also wanted to encourage discussion among postdocs and graduate students. So we wanted to have a venue where trainees could come in an environment where they could share some of their ideas about not just the problems, but also some possible solutions. So what were some of their ideas for tackling some of these issues? And in designing this symposium, we sort of came up with this list of issues that we kind of wanted to cover. So these were the areas that we felt as the organizing committee were sort of the most important to discuss at this point. So this included how we evaluate science and people's contributions, the efficiency of research and how it's communicated, the funding structure, the focus and duration of training, the sustainability of the workforce, and also what are the causes and consequences of the competitiveness that we're seeing in the system now. So to start off the symposium, we had a keynote speaker and a couple panel discussions. So these were Henry Bourne came as our keynote speaker. And you can see from the panels that we also tried to cover a range of levels in the scientific enterprises. So we had people from academia, including Marc Kirschner, Galit Lahav, Graham Walker, who are all professors at different levels. So Galit's more junior, the other two are more senior. We also had people who function as sort of dean of postdoc offices with Sibby Anderson-Tompkins and Cynthia Furman. We had representatives from industry with David Glass and Rich Roberts. And we had also an economic perspective of sort of the system and how it got to be where it is from Michael Teitelbaum. So we hope that this would give sort of an overview of the system, but from different perspectives, and give postdocs and graduate students some insights into how the system functions. And so we really wanted to include a lot of time for question and answer, which you'll see today. We also have the same thing. We think it's important to really be able to have a discussion going and not just have a few voices telling the rest of us what we should be thinking. But as you can imagine, this is sort of a huge topic to cover, and so we wanted to try to focus the discussion. So on the second day, we had workshops that were centered around these 4 questions. So we asked how we should be preparing trainees for careers, what is the structure of funding, and how do we want it to have it promote the outcomes that we're looking for. Can the current system of incentives be fixed so that scientists and institutions are rewarded for the behaviors that we believe support good science? And also, how can we match the supply of graduate students and postdocs to the demand for jobs in order to create a more sustainable workforce? So each of these questions represented one workshop, and the way that we ran these workshops was based on a method that was introduced to us by Manu Sarna. And the way that this worked was that we had groups of about 20 people with one or two moderators. Everyone was given a pile of Post-it notes and some markers. And this started off with first having people just on those Post-it notes list what they thought the problems were and put these up on the board. So this gave everyone a chance to sort of voice their idea of the problems. And then we really wanted to get to solutions and not just focus on the problems. And so once we had sort of an idea of where we were on the problems and the categories that these sort of fell into, we asked people to then share their ideas on possible solutions. So this was the same way with the Post-it notes. And we found that this was a really effective way of moving the conversation forward and getting to possible solutions, and also sort of helping to facilitate discussion of those solutions and some ideas that go along with it. So some of the problems that were identified, many of these I'm sure will be familiar to a lot of you. There was a concern about a lack of training, particularly in soft skills or in getting jobs outside of academia. So there was comments about training being too academically focused. There were also concerns that related to a lack of transparency. We realized, like people were mentioning, that we often don't know where graduate students and postdocs end up after their period of training, or how many postdocs are there actually in the system. There were comments about the structure of the workforce and issues raised given the fact that most of the work is done by students and postdocs, and then there are fewer and fewer positions for these students and postdocs to move on to within the academic system. There were mentions about funding mechanisms, so that there's not many options for postdoc independent funding, and various other issues that are, I'm sure, familiar to all of you in terms of how funding is awarded and the way that it works. Along with this was sort of funding priorities. So there were concerns mentioned about that funding is not necessarily promoting innovation, but it may be too focused on certain areas of science or on safe areas of science. And finally, another problem that was mentioned was this idea of hypercompetitiveness. And so concerns about people, the limited amount of funding, limited jobs, competition for papers, et cetera. So what came out of, so we have sort of this list of potential issues, but what came out is some ideas of things we could do about this. So how can we make the system better? And so some of the proposed solutions by the participants included broadening training. So I think we'll be hearing a little more about this from some of the other speakers as well, but this idea of including more sort of professional training in terms of soft skills, training that will be focused on things beyond research. There were suggestions made about changing the lab structure. So these included things from reducing the lab size to including more staff scientists or to having more core facilities for research. There were suggestions to diversify funding mechanisms. So primarily the ideas that came from this section were ways to include more postdoc-specific funding or funding for postdocs that were independent from research grants. There were also comments about changing the rewards and incentives. So rewarding people for community-minded activities, such as rewarding people for reviewing papers, serving on study sections, rewarding people for publishing negative results or making their data public access, these types of activities. And finally, there was some interest, there were comments that the scientists should be better at interacting both with the public and the government in terms of making it clear to the general public and the government why science is important, what it is that we do, and who we are, so that they'll be on board for continued funding of science. And if people, this is just sort of an overview of some of the things that came out of the meeting, and if people are interested in more of what came out and also the specifics of how the meeting worked, I recommend that you look at our report from the meeting and on F1000 Research. It's a nice sort of summary of what happened in the meeting. So with about 3 hours of discussion, we came up with a lot of possible solutions. And so we, as the organizers, wanted to try to find some overarching themes that came out of the meeting. So based on some further discussions after the symposium, the organizers came up with our list of 3 recommendations that we think can be a starting point for how to move forward. So the first recommendation was to increase connectivity. And this is something that can be done easily by individuals. So this was an idea that postdocs need to connect more with one another. Postdocs are often very isolated in their labs. And so the idea for junior scientists, postdocs, graduate students to meet others within their institutions and across institutions, but also to get to know other stakeholders in the scientific enterprise. So for postdocs to interact with senior faculty, people from industry, to really be a part of the conversation in terms of how we can change the scientific enterprise moving forward. The second recommendation was increased transparency. So the main part of this was to increase just access to information on the number of trainees, their career outcomes. So there was the suggestion that we could have some sort of a website which collates information from across institutions, so institutions could collect information on the number of their trainees that they have, where these trainees go on afterwards, so that this can give people an idea of sort of what is the reality of the situation, and also people can make a more informed choice when they decide that they want to pursue a career in research. We also argued that there needs to be a better definition of a postdoc. So I think many people would argue that what a postdoc is, the balance between training versus employment is often unclear, and it can vary widely from place to place. And so there needs to be a better definition of what a postdoc is and what the expectations are for that role. And finally, we would recommend an increased investment in junior scientists particularly. So a couple ideas from this were to separate training funding for postdocs from research grants. This would give postdocs more independence in their research. Another possibility would be to have postdocs and trainees provide anonymous feedback on their training experiences and outcomes so that we can have increased accountability for the quality of training. I didn't know I would have a musical background. And so that this feedback could be used to have a training score that could be used to hold institutions or departments accountable for the training that they're providing. So many of these recommendations will require, they'll require people from different levels, so we'll need both the NIH to be involved, junior faculty, senior faculty, postdocs, to get on board to make any of these changes. But there are things that we each can do as individuals, especially this is geared more for sort of junior people, so graduate students and postdocs. But we definitely really encourage you to get involved in the conversation. So to inform yourself about the issues, about the structure of the system, there are some very easy ways to get involved. You can become a member of the National Postdoc Association if you're a postdoc. Graduate students also can get involved with their local groups. You could become involved with societies such as ASCB that has a policy arm, which people could get involved with if they want to be more involved with the policy issues. Other societies have similar mechanisms that you can get involved with. And we also would love to recommend you to follow us at futureofresearch.org. So we're currently in the beginning phases of making our group into a nonprofit so that we can continue to hold meetings and symposiums and other activities for advocacy and sort of promoting understanding and information on these issues. And so with that, I would like to thank the tremendous group of postdocs and graduate students who were involved in putting together the symposium and the report and who are continuing to take this forward as we begin to think about becoming a nonprofit. It's been a fantastic group of people. I've not listed all of them, but these are a lot of them listed here. And we've also had a great group of advisors who've sort of helped us with a lot of the details of how to do this and have been very supportive in all of our efforts. And thank you very much. And I guess we have time for a few questions if there are any. And if not.
Is this on? I'll just shout.
I think it's on.
Oh, okay. Erica Sabrasi, ASB&B, American Society for Biochemistry. So I think that getting more investment in junior scientists is very important, and I think probably most of the people in this room agree with that. How do you suggest getting buy-in from more senior faculty? Because this has come up multiple times, and I think that it's a little bit of a hard sell sometimes, because a lot of the senior faculty feel like they're already taking a hit. They'd have to take an additional hit. Can you talk a little bit about that?
Yeah, and I think Jon Lorsch is going to talk a little bit about some of the issues that may be affected by this. So you're right. I think everyone feels crunched with funding right now, and so that can be a hard way to convince people. We've been surprised to find that as we've been going through this, that a lot of faculty have been actually very supportive of our efforts in this idea. So I think part of it is just starting to have conversations with faculty. figure out where they're at, try to get some allies as well and people you can talk to. But I think it's also important to remember that postdocs and graduate students make up a huge part of the workforce. And so it's important to sort of support them and help them, and that is, in the end, is good for the entire scientific system. So I think keeping this sort of in terms of what's best for the whole system and for doing research most productively and in the most innovative ways is one way to start framing the argument for a lot of these changes.
Carol Grider from Johns Hopkins University. One of the things that you had up there under your recommendations was changing the incentive structure, and you had some sub-points listed under there in terms of rewarding community-mindedness. Is there any way that that can be fleshed out a little bit more about what are the ideas to change the incentive structure? And is that something that you'll have going forward on your nonprofit?
Yes, so I think that will be one of the areas as we move forward. It's interesting because, so I think in terms of, so specifically people were very interested in sort of having rewards for having more sort of open access data or publishing negative results. How you actually change the incentive structure is, I think, a harder question of sort of how you encourage people to actually do this, and that's going to require buy-in, I would argue, from funding agencies or committees at universities who make promotion decisions, things like that. So to really encourage institutions to start looking at are people serving on are people serving on committees? Are people working on study sections? Actually taking some of this into account.
The other thing was just an informational thing. I was a member of a committee of National Academy of Science, the National Research Council, which has a report that's going to be coming out on the postdoctoral experience. And one of the things that's addressed in there is this issue about defining what a postdoc is. And there are recommendations that will be laid out in there, and it should be coming out anytime soon.
Oh, perfect. We look forward to seeing that.
Raquel Holmes, Improv Science, Boston University. I was thinking two questions. One is, what do you think you need or the postdocs need in order to get some of the recommendations that you already have in place kind of more bought into? And I was thinking, even with the comment of the question of the PIs, there's a question of, as you already went to, the different institutions and organizations. What could they be doing, both not just to support the symposium, but again, the kind of the restructuring of our postdoc? What would be some visioning of that?
So I think some institutions are already doing this in terms of through postdoc offices offering a lot of career training in different areas. I think encouraging that among other institutions. The National Postdoc Association has recommendations of sort of what they believe are the career competencies, so really encouraging institutions and departments to take a look at those and incorporate those, and allowing their scientists to take advantage of this sort of career development as well would be important.
Levery August, Cornell University. Wondering if your group has thought about the BEST programs funded by the NIH, and whether you want to comment on that?
Yeah, so I think we're going to hear a little bit more about those maybe today. But no, I think they're a great start, and I think having more of those programs, and hopefully we'll see after, I believe this is sort of the initial phase, and hopefully those will expand to more institutions. So it does, I think that's a great way to really encourage institutional change and to see more career development. And I believe Connie Lee is going to mention this in her talk as well, so you'll hear a little more from her about that. All right, thank you very much. Oh, Chris. How do I pull up the, yes, there's a toggle Alberts apparently. So, yeah.
So while Kristin pulls up the next talk, it's my pleasure to introduce Bruce Alberts, who is the Chancellor's Leadership Chair in Biochemistry and Biophysics for Science and Education at UCSF. He just received the National Medal of Science from President Obama. He's former editor-in-chief of Science, served as president of National Academy of Sciences, and on and on and on, you know. But he is, of course, also one of the authors on the infamous PNAS article, Rescuing Biomedical Research from Its Systemic Flaws. And the title of his talk today is Incentivizing More Innovation and Some Thoughts About Lab Size.
I supposed to use? Is it? Oh, this? Okay. Well, I made a mistake of trying to register. And they should have had a motorcycle to take us back and forth after the International Roundtable. So I'm going to talk about some general points before several of my colleagues talk about specific issues from our paper. So just as a brief introduction of where I'm coming from and where I get a lot of my prejudices or opinions about how to improve the enterprise is I was once a research scientist. I worked on this model organism, one of the first organisms that was used in the early days of molecular biology. You'll remember the Hershey-Chase experiment, for example. And to summarize 30 years, we discovered, well, of course, along with the work in other labs, that DNA is replicated by a protein machine, amazing process that enables us to walk and talk. Some personal level lessons learned. Unlike what we first thought in the 1960s when my cohort were graduate students, the chemistry of life is enormously sophisticated, and in fact much of it is based on sets of 10 or more proteins that work together to make what we call a protein machine, many thousand different protein machines in our cells. Secondly, and very important for thinking about how to support research, there are remarkable homologies between living things. Therefore, starting with model organisms wherever possible is really a shortcut to understanding humans and human disease. And finally, nearly all cell processes will be based on elegant mechanisms, and we need to do experiments to find them. So we just finished the 6th version of this gigantic book. And each time we write an edition, we're humbled by how much we still don't know. And to highlight that this time, because students get the idea that when you read a textbook, because we write about the things that we know, that they think that when you interview students, which we did, that 95% of what we need to know about cells, we know. I think that those of us who work have been around for a long time and write textbooks realize that's completely backwards. Probably 5% is what we understand. So this time we add a new feature at the end of each chapter, what we don't know, and we have more than 100 of these. And that was one of the most enjoyable parts of producing this edition, actually, working with the other authors to come up with these. But to get to the point, my conclusion from all this is that we're far from really understanding what we need to understand about cells and organisms in order to effectively intervene in health and environmental issues that everybody wants to attack immediately. But unfortunately, and this is a major point of our paper, the NIH has been overemphasizing so-called translational biomedical research at the expense, not that it's not important, but at the expense of the kind of basic research on biological mechanisms that we know will be crucial for improving human health. And to a large extent, this reflects politics. Congress, disease lobby, they want us to stop satisfying scientists' curiosity, end quote, and start working on their disease now. So this reflects, of course, the fact that they don't really understand biology. How could they? So it's up to us to get this message to them. Model organisms still provide a critical shortcut today to understanding human biology. I did a little count in our chapter on the development of cells and tissues, development from embryos to organisms through formation of tissues. And that chapter mentions in the text Drosophila 50 times more than 50 references to Drosophila, which is 4 times more than the next most cited organism, which is mouse. I think my favorite editorial that we published in my 5 years as editor-in-chief of Cell is this one by Huda Zogby. I want to make it clear that Huda is an MD who started out as a clinician. So all these kids she was trying to treat with Rett syndrome, she said, I can't treat them. I want to learn something about this disease. Became a researcher. She's probably one of the most outstanding translational researchers in the world, studying the basis for Rett syndrome and how she could intervene. And so what she points out in this editorial is the fact that I just emphasized, the overemphasis. She says, today many highly qualified basic scientists feel compelled to jump on the translational medicine bandwagon. And this is a quote, this wonderful quote from her editorial, based on the fact that she grew up in Lebanon, and she obviously, her first language wasn't English, so she could say this much better than any of us, or at least than I could. She said the challenge in translational medicine is that scientists are trying to translate a text with the sophistication and depth of Shakespeare using a first grader's vocabulary and experience. So, I would claim that to keep science healthy, we must refocus on our way we dedicate how we train young people, and the NIH must make it clear that fundamental research is really going to be heavily supported. In addition, we need more innovation. And this is, again, another point in our PNAS paper. I have this wonderful quote from a famous French mathematician Henri Poincaré, about the source of creativity in science. He said, to create consists precisely in not making useless combinations and in making those which are useful and which are only a small minority. Invention is discernment choice. Among chosen combinations, the most fertile will often be those formed of elements drawn from domains which are far apart. And this is a critical point because, we need to expose our young scientists to a broad range of ideas and knowledge if they're going to be creative scientists. And he then said the true work of the inventor consists in choosing among these combinations so as to eliminate the useless ones, and so obviously the vast majority are useless. So being a scientist is very much about being creative in the same way as being an artist is being creative. And when you think of it that way, you could explain the fundamental reason for the explosive growth of science, because it's just combinatorial. The more things we know, the more things we can combine. And it goes up exponentially in this, as explained in this slide. So if I make a diagram of my career, of course, we all build on the work of others. And working on DNA replication, we couldn't have done anything without these ideas and approaches from many other people, but we didn't have nearly as many opportunities to combine things as we do today. And of course, many of those combinations have led to new methods that also show how the power of science increases and helps it be ever more powerful. But there's a major catch. There's so many experiments we can do that we shouldn't do. We have the problem of finding the right combinations. It's too easy just to plunge ahead with things that we're familiar with. So how do we improve the enterprise? I've been a big advocate for small labs for a long time. And in general, I think we should encourage our institutions to support a set of laboratories of modest size, something like 9 to 12 people, each headed by an outstanding, innovative, independent investigator. These laboratories should be clustered, embedded in a cooperative culture which techniques and equipment are freely shared. That's a critical aspect of not wasting resources, and in enabling labs to be small, so you don't have to develop all the methods in your own lab. Of course, very importantly, as my colleagues will discuss, our reward systems must change to strongly encourage risk-taking and originality. I'll talk about that in a second. And finally, everything must be done to encourage a random collision of people and ideas. This meeting is a great example of that. I encourage graduate students to go to seminars if they can only go to 2 a week. Go to the 2 that you don't know anything about, so you're going to learn something new. Of course, that's not the normal way one thinks about it. And this meeting is a great chance to go to posters or talks in areas where you really can gain a lot in the way of new ideas and new approaches to your own work. And I wrote this article, this is the essay in Cell in 1985 that got me into trouble, which is why I ended up being a science bureaucrat, because this was the article that got me involved in science policy, but basically I still believe much of what I wrote in 1985 about the fact that a PI should be able to be close enough to the lab and have a small enough lab that he or she really does some experiments once in a while, knows what the limitations of techniques are, has time to read and think, and has the ability to really start new things and change directions, which is very hard if you have a big, large enterprise. So just to end, what might we do about this? To encourage innovation, a larger proportion of research funds should be devoted to funding that is focused on novelty and risk-taking. And I have a particular bold proposal that I'm presenting just because I think we need to start to get specific in what the NIH and others and what universities and all of us might do to improve the current situation that was actually beautifully described in that report from the postdocs that was published recently from that conference in October in Boston. So here's a bold idea, just put up as a way to start thinking. Could we increase the number of new innovator types of awards? I've been a reviewer for that in multiple cycles, from 50 a year, which is it's been for like 10 years, since it began, maybe 8 years ago, to 500 years, so that this becomes the standard way for funding new investigators. Specifically, that kind of grant emphasizes risk-taking and innovation while strongly de-emphasizing preliminary results. If we don't get away from preliminary results, we're not going to enable anybody to do anything new. And I would review all these applications using broad groups of outstanding investigators to avoid the silos that are presently created by study sections. And just my last slide is this striking data that some of you may have seen before, but this is from a little workshop we had that dealt with some of the facts that most of us don't even know. But it turns out, shockingly, if you look at that blue line, the number, absolute number, even though the number of total NIH grants has gone up considerably since 1982, the absolute number of investigators 36 or younger has dropped with independent grants, has dropped from something like 2,600 to about 600. So my question would be, how might such grant mechanisms be designed to recover the 2,000 young independent investigators that we've lost since 1983? Thanks.
No one else has a question. I'll ask one at the moment. So, I am really intrigued by this proposal to reduce the need for preliminary data for new investigators. I'm wondering if you think that this opportunity to engage in a new direction should be limited to new investigators, or whether this should just be a reduction of preliminary data for all grants.
Well, if you're trying to continue what you're doing, I wouldn't say that people should never continue what they've done. that would be crazy. And so I think preliminary data makes sense when you've been working on a project and you want to continue it. Sorry. When you're working on a project like I was working on DNA replication for 30 years and I want to continue it, you want to know what I've done. I mean, and I want to know what a young investigator's done too. And as a reviewer of the new innovator grants, I'm looking for people who've done something.
Yeah.
But they don't have to have done what they want to do now. That's the difference. So the trouble with young investigators requiring preliminary data is that means you're going to do what you did in your postdoc, which means that fields that already have lots of people in them are get more and more crowded, and the enterprise becomes more and more, can I publish 2 weeks before this other group? And what's the point? I grew up in a lab at Harvard where, this is amazing, you may not believe this was ever true, we didn't know what the genetic code was. And so Nuremberg discovered this poly-U could make phenylalanine in many labs, including mine, not me, but graduate students and postdocs in the lab I was in were racing to find the next codon. And I thought, they were always, 2 weeks behind the next, either Nuremberg or Corona. But my whole feeling, what's the point of even doing that? Because somebody's going to do it. If you're a scientist, you got one life, you want to do something that makes a difference. And so we're not allowing young people to do that. And that's the real disaster. And to get to this slide here, I mean, I'd be interested in what Jon thinks of this, but basically, the U.S. scientific enterprise has been unique in the world in tracking people from all over the place because we gave young people a chance who were outstanding to do their own thing. And nobody else in the world was doing that. Now Europe's probably doing it better than we are, and we're doing it very poorly. So what does this mean for the whole future of the U.S. scientific enterprise? I think it means disaster unless we do something about it. What a brilliant young person is want to become a scientist when they could go to Wall Street and make 10 times more, or a computer company, go into private business and make more money if they're going to have to wait till they're 42 to get their first independent grant. I wouldn't have done it. My generation, we had our own grants below the age of 30. We started assistant professors at 28, something like that. We can't probably do that, but we could do a lot better than we're doing now.
Yeah. So one of the reasons that it's so much harder to get the young people in is that they're starting their jobs much later because they're having much longer PhDs and longer postdocs, and so that's all part of this equation. Do you have similarly bold recommendations for addressing that?
So another thing that's happened is that since they're not going to get their first grant, universities got to offer a $1 million startup packages, which is breaking the universities. So and they are afraid of hiring anybody who's not really senior because if they don't get a grant in the next 3 years, then they're going to have to support them or something. So we have a terrible system. So just off the top of my head, could there be a grant system that that selects special people, gives them the equivalent of their startup package, and then thereby incentivizing the university to hire them? I mean, so. Yeah, of course. So the New Innovator Award, you have to be within 7 years of your PhD. So you could have a sub-fraction of that's within 4 years of a PhD. I mean, if you wanted to drive the age down. But, I've been terribly frustrated with the inaccessibility of NIH central offices to really open up this discussion. Jon is a great exception. Yeah.
Hey, Kenneth Gibbs, speaking a little later. So, just a question, or one comment about. Well, I'll do my comment during my own time. But question: why do you think it got this way? Because I was born after this chart started, and I've done all my science training, and so I hear about all this sort of good old days kind of way that we talk about what science used to be, and I'm curious, how did it get this way in your estimation, and what are the, what's the concrete step? Is it shifting money? How did it get here?
Well, it's very simple. I mean, you could easily explain how it got this way. We got more and more people, too many people for the number of jobs, and so you're in a holding pattern longer and longer as a postdoc, and you're supposed to be basically famous before you get an assistant professorship. I got a job as assistant professor when I had done nothing, really. You'd have to laugh at my CV, but I don't. But that was because there were very few PhDs coming out in this new field of molecular biology, and departments wanted to hire us. So we're not going to get back to there, but what can we do to select the very best people to get out of this hole that we're digging for ourselves? Jon?
So Jon Lorsch, NIGMS. Bruce, your idea about having the NIH take over some of the startup package funds is actually, believe it or not, something we have been floating at NIH. But there's obviously not money just to do that, unless we take it from something else, or we use it to leverage some other kind of benefit for the system. So putting on your academic hat here, do you think the universities would be willing to trade some of the responsibility for startup funds and give it to NIH in exchange for actually taking on the burden of paying faculty salaries in the long term?
I think that'd be a great thing to offer. I mean, you can hear from my colleagues about all this, but I mean, I came to UCSF in 1976 first I was at Princeton, and then for 10 years, then I was at UCSF. In both places, having a faculty slot meant that they paid 9 months of salary. All I had to do was cover 2 months of summer salary or with my grant. And if I didn't have a grant, I didn't have a summer salary. But just looking at my university, I wasn't paying attention because I was away most of the time. But now it's something like UCSF pays on average 27% of salary because they could. And NIH let this happen. And so I think we have to get back, and I think that's a great thing to think. I'm very pleased to hear that this has been being seriously discussed. I mean, the universities are not rolling in cash. They're not, but how much? It would be good to have data. How much of their expenditures, all the startup packages, where do they get all this money from anyway? This is many, many millions of dollars they have to spend to hire faculty every year. I don't know what the data is, but yeah.
Erica Sabrasi, American Society for Biochemistry and Molecular Biology. So I'm curious what you think of Representative Andy Harris's ideas about how to bring down the average age the first time you receive an NIH grant. He basically wants to legislate this and force the NIH to do it. And so I'm curious what you think about that, because I think it's something that we as a science community need to realize is probably going to be pushed into 21st Century Cures Act. And so I think we need
I was in Washington for 12 years with government. I think whenever government gets involved in that way, it ends up being bad. Because they don't understand. I mean, I like the idea that he proposed it. Maybe that gives the excuse for the NIH to do something. Because, of course, the NIH is reacting to the world of politics. For one thing, you've got all these old guys like me who got grants and don't want anything to change. We've got a lot of people who are invested in the present system. And every time we propose something, those people are very active in well-connected and threatening to go to their congressman and God knows what else. So we need pressure from the other side. Hi, Carol.
Carol Grunder, Johns Hopkins. Your idea about a smaller lab size I think is a really terrific one. The question is, how do we go from here to there, and what kinds of approaches can there be, and would, in today's environment, smaller lab sizes really mean more time to think?
I'm glad John is here because it's not his responsibility, but I was on the Committee of Scientific Review Advisory Committee for 3 years, and it was the most frustrating thing. We couldn't get anything done because we had no responsibility, we didn't have data, nobody wanted to give us data. But one of the group that I was part of, it was a good group of people, we all felt almost unanimously that NIH grant applications should show how many resources you had before, they used to. When I was the head of a study section in the early 80s, we knew how much money somebody had, and therefore we had a rough idea how to measure their productivity. Today you have no idea what somebody's productivity is. You don't know how much resources they have. So obviously we're driving it in the opposite direction. We are driving, all the incentives are to reward people with a lot of money, more money, because they publish lots of papers and we don't know how much money they had, so we can't have nothing to divide by. Well, this is a no-brainer.
Our next speaker is Connie Lee. She is at the University of Chicago. She's the Assistant Dean for Basic Research. She's also in the past been the editor of EMBO and the deputy editor of Cell. And most recently, she was the Associate Director for the Center for Systems Synthetic Biology at UCSF. She's also the chair of ASCB's Public Policy Committee, and in that capacity has led a task force on reproducibility in science. The title of her talk today is Challenges from the Perspective of a Research Dean.
Okay, so can people hear me? Yeah. Thank you, Jessica, for the introduction and for the invitation to speak on this distinguished panel. Admittedly, I've only been a research dean for about 9 months now, so when Jessica first asked me, I had been there maybe 3 or 4 months, and I said, "You realize I've just started this job," and she really, wouldn't let me back out of this, and so I show this slide just to show you that I've only been there a short time, so. With the caveat being I may not be able to answer all your questions because being in the dean's office, there's really a lot to learn. I also show this slide just to kind of show my diverse background and to kind of give a shout out for all different kinds of career opportunities in the sciences. And so Jessica asked me to speak, to answer to talk about some of the tough issues we're dealing with in the dean's office. And so my talk actually follows Bruce's talk very well. And this is, again, my experiences now at the University of Chicago. And this is just to give you an idea of the scope and the size of I'm at the assistant dean for the Biological Sciences Division. And we have about 10 basic science departments, so about 137 faculty in those departments. However, we have the hospital as part of our division, and so have many clinical departments. And we also have a lot of research faculty. We have faculty that are focused more on clinical care, but we also have a lot of research faculty in the clinical departments. So altogether, we have about 400 faculty doing research in the Biological Sciences Division. And I didn't want this to be strictly a budget talk, and by no means am I a budget expert, and I'm learning, I have a lot to learn about the budget process at the university. But my main point here is to emphasize we have a lot of different funds revenue, again, because we're part of the hospital provides part of their profits that is diverted to support the basic research. And what I want you to notice is that the $897 million total revenue, and you'll see in the next slide that all goes out in expenses. So we are actually mandated by the university to have a balanced budget. So we cannot go in the red. And another thing here that you'll see, one of our largest costs is compensation. One of our largest expenses is compensation, net of recovery. So this is a little bit of a depressing slide, but it's obviously Bruce talked a little bit about the 9-month salary package for a lot of faculty. So with a lot of medical schools, medical campuses, they are on a 12-month salary plan. So the universities do have usually a target for you to recover part of your salary off of grant money. And I emphasize the word target here. As you can see from this slide, this is a 4-year trend for all the basic science departments at the University of Chicago. And as you can see, the trend does not look good. And what you can also see is only about 3 departments are somewhat reaching that target. And so obviously this is a bit worrisome for us at the university. Again, in FY14, the average salary recovery was 34% across all 10 basic science departments. And again, I emphasize the word target. We do not penalize faculty. We still pay them their 12-month salary. And obviously this, is a large consideration for us. And just to give you a few more numbers about the funding, as you know, the NIH budget has been declining, and as you can see here, the NIH funds to University of Chicago have also declined as well, both in, so here it's shown in total dollars. On the right-hand scale bar is the funds to the basic science division, and also in percent of awards. And you can see there with the stimulus money, actually University of Chicago did not do very well as far as getting a larger chunk of that stimulus money. We actually had a lower percentage of the actual NIH funds. And just one of the last sort of numbers slide I'll show, we've been tracking a number of awards, and this is all mechanisms, so not just federal grants, but also foundation grants. And while the average number of awards, again, this is all mechanisms, has been increasing, you can see there's been a little bit of a plateau as to the dollars coming in. So this, actually means the average size of the award has unfortunately gotten smaller. So just an overview, as some of the things I mentioned, so the funding, we've seen it go down as far as both in dollars and in share of the budget. We are already at the university in our fiscal year 2015, and we've had some indications that we're hopeful that 2014 may have been the low point for us. We've had some good numbers come in so far, but it's really too early to tell. And salary recovery has actually decreased overall, as an overall average, about 10 percentage points in 4 years. So just a rough back-of-the-envelope calculation, that calculates to about $2.2 million right there that we're not able to invest in the division. The number of awards has increased, but the average size seems to have gone down a bit. And so what is, from the division level, what are we doing? Well, we have been increasing investments into resources at the university. And I'll just give you one example here. In 3 years, our bridge funding, so this is when investigators have lost an R01 and need some bridge money to sort of tie them over to the next R01, our bridge funding has increased from $250 million a year to $1 million this year, and we expect that it's going to go up again next year. So the situation doesn't seem to be changing anytime soon, and so what can we really do to help our faculty? And I'll just give you as an anecdote, when I was interviewing for the job, we have the Uber dean, who's the dean of the medical school, the hospital, and all the departments. I asked him what is his number one priority, and he basically told me, helping faculty survive. And so that really kind of summed up the job for me. And so one of the things that we've been trying to do is work with our federal relations person to help investigators think a little bit outside of the NIH box. And again, NIH is great, and it's been really the largest source of funding, but there are, other pockets of federal money out there. And so we actually have at the University of Chicago a person based in DC who's really sort of establishing relationships with program officers at these different agencies. For instance, they regularly bring program managers from DARPA to visit some of our faculty. Turns out DARPA's been, funding a lot of basic science lately, and they've had a recent interest in ecology and communities, and we have a very strong ecology department, and our chair of ecology had never heard of DARPA, and so those are the kinds of connections we're trying to make. Likewise, corporate relations. There's a lot of interest right now from industry to partner with academics, and we've had some one-day workshops where the company has organized this at the university. We have maybe 10 faculty speak. It's all kind of about building relationships. And likewise with foundations as well. There's some money to be had there as well. I'll just give the caveat that with foundations and with industry, there can be certain issues that you're not used to as far as dealing with NIH money. Sometimes there's IP issues with foundations. And so again, it's all about educating the faculty about these potential restrictions and how they differ from NIH funding. And also awards and prizes, of course. We're trying to really be better about taking advantage of those and really nominating, getting our chairs to nominate our faculty. And at the university level, they have really stepped up with administrative support, especially for interdivisional, kind of cross-cutting, multidisciplinary approaches. And they know that those proposals are sometimes hard to get together when you're, working across divisions. And so, for instance, right now I'm helping the university office work on 2 NSF proposals for these large science and technology centers. And so that's, again, some of the things we're trying to do. Likewise, we are trying to boost some divisional resources, and I'll give you a couple more examples later. But again, I've already mentioned bridge funding. Grant writing workshops. We have 2 new deans for faculty affairs, and they've been holding grant writing workshops. And one of the things that I've tried to advocate for, again, probably because of my background as an editor, is getting feedback to scientists, especially junior scientists. And, grant writing workshop is one thing, but to actually, when you write your first draft and to get critical feedback on this, I think this is so essential. And I find that a lot of our faculty are not getting that right now. And one of the things we've been trying to do recently, this idea was brought to us by a faculty member, and it kind of follows up on what Bruce was saying, is how can we make our faculty more competitive? Like, can we bring faculty together in different types of forms? And we're trying to figure out good mechanisms to do this, where they can really innovate and build these collaborations. Because science used to be a little bit more isolated, where you could kind of do your own thing. But these days, to be competitive, sometimes you need to reach out to a computer scientist or a bioinformatician. So how can we help, make those connections? And that's something I'm, personally very interested in and really trying to help go forward. Again, some of the things that we've been trying to do to help is we started a listserv where we have weekly funding announcements. And again, a lot of these are fed to us by our government relations person, where she's constantly looking for new types of RFAs, really new types of opportunities that we're then putting out on an email to our faculty. And again, focusing on sort of more non-traditional type awards that people aren't used to looking at. We do provide some support for these applications, and including dean's letters. And again, with awards and prizes, trying to be more proactive about building relationships with societies and supporting these nominations. Just to give you a couple more examples of what the division sort of invests in, and we talked about this a little bit yesterday at council, there will be another point at the end. We actually have a very centralized office for shared resources or core facilities. And so not a lot of universities have a lot of core facilities anymore, but we really put a lot of effort into centralizing this and do invest in this. Animal Resource Center, of course, as well. And one of our largest investments over the last 6 years, I think it started about 6 years ago, is the Center for Research Informatics, where we provide faculty with computing and informatics support, storage. They can get help with sequence analysis, et cetera. And that is one of the largest investments right now in the division. So one of the things that has also come up is, we hear this again and again from faculty, especially young faculty, is how can they get more help to support postdocs and students? And one of the things, again, the division has done is a few years ago, they started a Chicago Fellows program, and these are fellows positions that are supported by the university. They're very competitive, and to be for a recently completed PhD and who's coming from outside the university. And what I find nice about them as well is that we have a little peer group of these fellows then where we get together with them quarterly. And this is one example where we can't afford to support as many as we used to. And we used to support them. We used to give 3 years of funding, and now, unfortunately, we can only give 2. But it's a nice, obviously, if you can get one of these, it's very helpful, if they haven't gotten their own fellowship. And this is also in line with a lot of private fellowships out there. And with graduate students as well, we're hearing a lot that our university only normally can support graduate students for about 3 years, and then the PI normally needs to take over. And we are working with the development office, and if there's any way we can get funding for our training programs. And I just came from UCSF, and they just got a large a donor to support their basic research training. And I think that's just fantastic. And if we could, I think every university is obviously trying to tap into that right now. And of course, more support for international students as well. Because since they can't be on training grants, this is a large concern. So I'll just sum up with some of the downsides, and then on the flip side, maybe some of the opportunities that the current funding climate has led to. So for the downside, it used to be that most departments would be approved for recruitment every year. And I would say in the last several years, this has not been the case. Usually we've had to limit it to about 6 departments. Again, I've only been there for less than a year, but this year we've awarded 6 slots. And this has frustrated a lot of departments because they would like, obviously, to be able to recruit every year. Even though sometimes they didn't get a faculty member, they still like to recruit every year. So we have had to sort of limit those slots. And you saw the size of our enterprise. So at least from the basic science departments, there was about 130 to 140 faculty. We've averaged 4 to 6 new recruits, I think, over the last 5 years. So again, that's not a huge number, but it has allowed us to remain, mostly flat. Obviously, with the downside being, there are definitely trade-offs between what you can do to support existing faculty versus recruitment of new faculty. Like Bruce said, recruitment is very expensive. And less money to go around, obviously, for new investments. We've had to be a little more strategic about that. And again, something that was mentioned already today, and this didn't necessarily used to be the case, but I know this is discussed during recruitment, is how fundable will this candidate be? So lastly then, what are some of the opportunities or some of the things that have come out of this current funding climate? I think one of the things is, probably the best thing is that it's kind of forces the division to be more, in the university, to be more strategic and cost-effective with funds. And what I've seen, which I've, again, having a fresh perspective of just being there, we've been much more strategic with partnering with other divisions. For instance, we just bought a cryo-EM where we partnered with the Institute for Molecular Engineering. And there was a couple of recruits where it was a joint recruit between the Physical Sciences Division and the Biological Sciences Division. So there's more of this kind of pooling of resources, which again is probably very, very good in some ways. One thing has been, which is kind of surprising, if there's, in tight funding times, getting a startup package, is obviously is great, right? And it's been it's allowed for more faculty to actually become movable, like faculty that you never thought would move. And so in some ways it can open up opportunities as well. And I just want to give a shout out to the BEST program from NIH. And University of Chicago was very fortunate to be awarded one of these grants this year. And I think it's been a tremendous opportunity for our students and postdocs that it's just opened up so many professional development opportunities for them. We have connections now with the Booth School, the business school that we never had before, with UC Tech, et cetera. And lastly, it obviously forces you to become, a little bit anticipating, areas of need and, future directions where there might be funding in the future. And I'll just give you one example. University of Chicago just recently partnered with the Marine Biological Laboratories. And, we've had a very strong evolutionary ecology program at University of Chicago. And so there might be future opportunities here with all the interests and need for funding climate to partner with MBL to work on some of these new, emerging areas of research. So I think that's all I have. So thank you again.
Connie, I wonder if you or anyone else has done an analysis of that pool of other funding besides the NIH, because the talk that you gave could have been given by our Vice Dean for Research and probably was just the other day, and there are probably hundreds of universities across the country who have the same idea about going to this other pool. And if the NIH pool is this big and the other pool is this big, it will be exhausted in a nanosecond. Yeah. So I'm wondering if anyone has done that kind of an analysis, and also if there are other discussions, besides competing better for a smaller pool, that are going on in parallel about changing some of the other structural things that
No.
lead to this?
Right. That's a great question. And no, we have not done any sort of analysis. And I agree. We're all probably now, chasing after these same other pools of money. But again, I think it depends on the area. Like certain faculty, maybe never considered that other pool. And it turns out they could be very competitive in that pool. And, if it's the right topic, for the right agency, it could be just a great source. But yeah, I haven't really done any analysis. And again, it is a small pool compared to the NIH pool, obviously.
Bruno Azevedo, UT Southwestern. I'm wondering, as a dean's perspective, because things we see nowadays is a lot of structural grants. So you have those new beautiful buildings and all of those structural things that the labs are empty because the faculties are not getting grants. So in a dean's perspective, how you think that you can talk to those funding agencies that actually we need maybe more grants for people and less for infrastructures?
Right. Well, we don't have any new buildings on the horizon, that's for sure. That's one of the things we've been telling faculty recently. And, we don't have any new buildings. So obviously, getting people grants right now is our biggest priority. So that's exactly what we're trying to help with. And like I said, we're not focusing on any new buildings.
Hi, Avery August, Cornell University. It seems to me that most large research universities are thinking about doing the same thing as was mentioned earlier. And I think it seems as if there's let's wait this period out and then things will go back to normal.
Yeah.
And it seems like there's a larger structural issue that needs to be changed that isn't being discussed. And I think one of them is how faculty are paid. We heard earlier about the 9 months versus the 2 months or 2.5 months. It seems to me that universities have leveraged flat dollars for faculty salaries by paying a smaller percentage of their salaries, but raising the number of faculty that they have. And it's done that through NIH funding, largely. And at some point, that's a lot of money that's going into supporting faculty and university operations that wouldn't be there if universities have to pay at least a major portion of their salaries. So I'm wondering whether these are discussions that are being had at U of C.
No, definitely. It's something we noticed in this past year with the recruits, that a lot of recruits are going to both college, universities that have the 9-month model and the 12-month model. And so we actually, are looking at this. Should we, again, we're not out of line. Most of the academic medical centers are on the 12-month salary plan. And again, as I tried to mention, our target recovery is really a target. We don't, obviously we're not meeting that at all, and so we're not penalizing for that. But it's something we're discussing. Is a 9-month, and I actually did an informal survey of a lot of recruits that I knew, and just because a lot of them then, I think with the tight funding climate, a lot of them are preferring the 9-month salary model where they have to get, then it's a bonus if they get a grant and can get their summer salary paid, versus the 12-month model where they feel like this is kind of a burden on their shoulders that we're expecting this recovery. Again, even though we're still paying their salary, they feel that it's more of a burden. And it's definitely something we're talking about.
All right, at this time we had a break originally scheduled, although since we are running slightly behind, let me just move over here, out of the way. Unfortunately, Tony Hyman can't join us, but very fortunately, we do have Marc Kirschner, who has been recruited at the 11th hour to step in his place. And so I am very grateful for this late addition. Of course, Marc Kirschner is the founding chair of the Department of Systems Biology at the Harvard Medical School. He's a member of NAS, AAAS. He's received the E.B. Wilson Medal. And the title of his talk is A Need to Identify the Principles of Science on Which to Base Policies for Scientific Support. So let's welcome Marc.
see, well, I have the perfect excuse for giving a disorganized talk. I mean, I didn't, I don't even know how to change this slide here. Oh, here we are. Okay, fine. Okay, well, I didn't find out about this until Jessica told me about 10 o'clock last night. And I'm more sorry than anyone else. Maybe I should say that. Maybe all of you, everybody's sorry that Tony's not here and I have to speak in his place. So I don't know how many of you have read this thing, which I guess Jessica called infamous, article that Shirley and Bruce and Harold Varmus and I wrote. We haven't heard it called famous either, so that's a sort of a designation of sorts. But it really dealt with the problems facing science, driven a lot by the nature of the workforce issues, also having all sorts of consequences. And I think Shirley is going to talk mostly about that. After that, there was some fallout, and one of the interesting meetings I had was a day I spent at the Center for Scientific Research. I gave a talk and spoke to all the study section people, and some by video conferencing, and it was very interesting because I think they feel they're the people carrying out a lot of the policies, and they feel as concerned as I think all of us feel. And they're aware of a lot of the problems. And I really felt it was necessary to try to not to provide more policy ideas, which I think in the end they're going to have to come by through some sort of working things out between the NIH, between maybe even Congress, between the institutions and scientists, and I hope with the real involvement of students and postdocs. Not just because they're the ones whose lives are going to be more fully affected by this, but because I think their perspective is extremely valuable in seeing how science is done in the laboratories, where the ideas are coming from. We need to really base things on our current experience. At the same time, I felt that history has taught us some general principles on which we could probably base some of our ideas about what kind of policies to carry out in science. And they'd be sort of a test of whether anything we do is really going to improve or worsen this present situation. So I spent a little time before I gave the talk to the CSR group of thinking about the principles before we got into the actual policies. So I thought I would do that today. I didn't know what people were going to talk about, and I didn't have much time to prepare things either. So I came up with a few general ideas that I think we should be aware of. We're aware of them at subliminal level, but we don't talk about them very much. Sometimes we don't crystallize them, and sometimes our actions work quite counter to these ideas, which I think are almost self-evident. And maybe I took my inspiration a little bit from the Declaration of Independence, which talked about truths being self-evident, and then came out with a conclusion that something needed to be done. But they did start out, at least, with trying to get those truths out there. So this seems self-evident, but a lot of our actions work counter to this. That science best proceeds in an environment of free inquiry, and in that free inquiry, we should make every effort to nurture iconoclasts, and one way in which we're not doing that is to focus on very practical goals. Those always seem eminently reasonable, but they're not necessarily the most, not only the most creative or the most important. And of course, that policy statement has flaws. We cannot support every iconoclast. We like to talk about those things, you know, give you some examples here of people who ran against the tide, did things against the common perception of the time, or went into areas that nobody else did. And we like to honor them, but frankly, most iconoclasts are nuts. You know, I mean, you've read. So we have to somehow distinguish a certain kind of spirit of free inquiry from just anybody who has some random idea. But in our effort to get rid of the nutty ideas, I think we would have gotten rid of a lot of things that just by accident or maybe by perseverance of these people ended up going counter to the tide and making tremendous contributions to what we now know. Maybe my favorite in this list, it's not the most important maybe, who knows, but one of my favorites is really restriction endonucleases. Now, everybody here, I think in the audience, has used restriction enzymes. The entire recombinant DNA world depended on it. Everything we've done, all the sequencing of the genomes, all the genomics, all the cloning, all the expression, all depended and still depends on restriction enzymes. And in this rather obscure field of bacterial immunity against foreign DNA, Ham Smith, Werner Arber, and with what's kind of German? Anyways, Nathan's. I forget Dan Nathan's. God, his Jeremy Nathan's. He keeps coming to my mind. It's his son, anyways. And all these people kind of found this a very interesting area of science. They followed it because of the excitement of the ideas. And when Ham Smith gave his Nobel Prize acceptance address, he said, even we had no idea what the consequence of this work would be, let alone the people in study sections. Interestingly enough, this CRISPR phenomenon, which of course is taken over, is another example of an obscure mechanism of bacterial immunity. And so maybe we should all be studying bacterial immunity. But in any case, this is the kind of thing we need to nurture. And I think the present system is working against it. The second general self-evident truth, to me anyways, is that science progresses most rapidly when scientists can focus most of their energy on science. Writing grants and papers can be stimulating. Rewriting grants and papers is not very stimulating. And the system we have now, dragging people through constant rewriting, constant reapplication, is a waste of energy. No matter how fair it is, how necessary it might be, it's a waste of energy. And the regulatory burden does not stop there. It's extended. Every time somebody has a good idea about animal welfare or something else, it adds a burden. And we will ultimately get to the point of, I think, having no time whatsoever of science, we're spending all our time applying for grants and filling out forms, and this is a serious problem. So just we have to remember every time we think about doing anything, any policy that's brought into the force has to really confront this question about what is it doing to the scientist's time. Another self-evident thing for me is that science proceeds best in a context of a lively, self-organizing community. And I've been part of such communities. I've seen such communities. There have been many of them. And these communities had some local autonomy, some common funding. They can rely on local judgments about risky long-term projects and the potential of individual scientists who have not been recognized by the world at large. As we make our system more and more fair, get rid of nepotism, we are also getting rid of a creative force in science. And we have to figure out a way of replacing that. Because no matter how good the system is, the best judge of how the quality of the individual and the originality of the science may be actually the colleagues that this person has in this department. All right, I can give you many examples for that. Effective communities are built from many types of contributors. Again, as we try to develop a template for the kinds of grants we want, the kinds of people we want to hire, we lose the fact that we don't want one type of person. We want many types of people. Not just those who publish in Nature and Science. We want pioneers who, in fact, may not make the big discovery, but lay the groundwork for others to make the great discoveries. We want colleagues who take the time to listen and to offer criticisms, to talk to other people's graduate students. As we raise the bar higher and higher, we eliminate those people, and science suffers. I don't know how to solve this problem completely, but I do know it's a problem if we do that. Okay, I think another obvious thing is that communication is the lifeblood of science. And publishing has become far too painful. We rely too much on a small set of journals. Reviews are often unconstructive and uncollegial. Grant reviews are influenced by the problem, with the same problems that journal reviews have, and they're all looking to see who's publishing in which journal, so the whole thing is one big feedback going off in some eccentric orbit. And of course, on the question is whether grant reviews should really seek consensus. I mean, are the best grants always going to be the ones that have 3 reviewers who think they're the best grants? I don't think so. In fact, I've suggested to CSR that maybe they should have just 1 reviewer for each grant, because in that case, what would happen is right now the chance of getting 3 positive reviews is small, probably less than having 1 positive review out of 3. And that I was surprised when I talked to some people; they thought it was a good idea. I meant it tongue in cheek. So there you are. Okay, so finally, this is tough for people who want to plan, but science is unpredictable. Focusing on whether a project is feasible does not necessarily lead to the best science. Bold attempts to do something new may fail, and yet may open up new directions. Somehow, investors understand that not every investment pays off, that the return on the investment, if it's very high, if it works, is worth taking a chance. I don't know why scientists don't feel that way. They act like they don't feel that way, and they actually discourage the behavior of risk-taking, the system that we have today. And I'm not blaming the people who are in the study sections, or the people on the CSR, or the people who review papers. It's all of us that have somehow created this system. I also feel that this distinction between basic and applied science is pretty unsupportable. Great basic science almost always inspires new ideas of practical outcomes. Witness the restriction endonuclease examples I gave you. In many cases, the greatest advances come from basic science. And if we misunderstand NIH's wish to encourage translational science, it would be just to focus on the most practical things. That's probably not the best way to assure translation. And I think we're telling some people what they want to hear. It would be great to be able to say that we've figured that all out, and all we need to do is sit down and work harder on the things we know. I'm not sure I'd be a scientist under those circumstances, but if I suffered from a disease, I'd be happy if that were true. It's just not true. And we have to steadfastly support that. Okay, well, I end with a quote, which some of you may know. So how do we tell what a good scientist looks like? I mean, that's what we're all trying to do when we're hiring people. And this is from Peter Medawar, who really is probably the person who began the adaptive immune system, as we understand it. And he said, scientists are people of he's one of the people of transplantation immunology. Scientists are people of very dissimilar temperaments, doing different things in very different ways. Among scientists are collectors, classifiers, and compulsive tidiers up. Many are detectives by temperament, and many are explorers. Some are artists, and others artisans. There are poets, scientists, and philosophers, scientists, and even a few mystics. And most people who are in fact scientists could easily have been something else instead. So I think we should try to put aside this template idea. I guess the last thing, if I have a moment, which I came up with was a way of testing whether we should support somebody. It's sort of a Godonkin experiment, and it comes from the fact that if you have a flask of water, a 1 liter flask of water with a line on it, accurate flask, and if you add 100 grams of sodium chloride, the level of the water goes up. If you add 100 grams of magnesium sulfate, actually the level of water goes down. What I'm saying, what we really would like to do, and which is very hard to know, is funding a scientist in the context of the whole community. Does it increase the volume of that community, or does it decrease the volume of that community? And that he may or she may do that by enabling the work of other scientists, by teaching or training other scientists, by carefully explaining their work, or by doing work which ultimately will benefit, but which doesn't come out as a benefit in the short run. We need to realize that this is what we want to be able to do, what we can't do, and think more broadly about who we fund and how we fund them. So there we are. We have a positive and negative contribution. And finally, just we have to return to these abstract fundamentals, even though they don't tell us exactly what to do, because ultimately I think we should judge all of our policies against these fundamental goals.
First, I'd like to ask a question that came in via Twitter. The question is, what is your take on patronage in terms of funding? So I guess accepting funding from non-traditional sources and how that could impact the practice of science.
Well, I was working with a fellow in my graduate work at the time of the Vietnam War who accepted funding from the United States Navy. And his view was that I don't like the Navy so much, but every grant I get is a few fewer artillery shells. On that basis, I think I'd be willing to take money from, I'd have some limits, but I don't think it's terrible to take money from people who are giving money for basic research. I wouldn't put a political litmus test on it. I don't have to support their views of life. I mean, I wouldn't judge anyone negatively about it. This is what I say.
Hi, can you expand or clarify? You made a comment about sort of local communities. You said as we move away from nepotism, move towards fairness, there's a creative force that goes away. I think that's what I heard you say. And if not, can you clarify?
As we move away from...
You said...
Well, I mean, we're very hyper about, wanting to judge. When we judge a person who's... for example, to be promoted in our department. The importance of the comments is proportional to how far that person is from that individual. So that if somebody from England says something good about them, it must be really important, and the next door neighbor says something good about them, that's very unimportant. It's a natural to why that should be the case. In some ways, this could all be very corrupt. But I do feel we have to think about communities, large communities, small communities, supportive communities, and I don't have an answer as to how to do that, but I think we've gone to an extreme in trying to not take into account other types of contributions that people make.
So one of the themes that seems to be going through the whole session is trying to find ways to change policies to improve the scientific enterprise, make it more possible to make groundbreaking, transformative results. And I wonder if anyone has done a study of what the parameters of the laboratories are that have made those. For example, so most of the examples I know are very small laboratories that have made groundbreaking results. And I think it would be really interesting to actually, first of all, define what it means to be groundbreaking and transformative, which I've never seen a definition. Everybody seems to know what it is, but I haven't seen a definition. And secondly, to try and identify those labs that have made those over the years and ask, what do they have in common? And actually have that kind of data to help us drive our policy forward.
No, I think so. I mean, Mendel had a very small laboratory as far as I can. But he had free time to do his work. Jan Uslein Volhart and Eric Wieschaus worked in a larger community, but they had the freedom to take an original direction. Yeah, no, I'm saying it's small. I'm not disagreeing with you. I mean, twice as much as Mendel, but still a small effort. On the other hand, they operated in a larger context that gave them the freedom to do that. So I think yes, I think in general the great discoveries have been made by small groups of people or individuals, and that should be studied. My guess is we'll see a lot of different kinds of models, but we also have to think again about these communities. And why was the Laboratory of Molecular Biology in Cambridge so fertile? Why was the biochemistry department at Stanford at a certain point so fertile? There was something about the way they worked, and I think we need to study those things. I agree. I think we need a book on the subject, and it'd be interesting to see it. There are probably many different examples. And also because these places also trained effectively very good people who went out and did great work. And as we want to bring more diverse people into the communities, they should be training in such environments, I think. Yes.
I came up actually just to echo and appreciate your identifying communities as an important component. It's definitely a feature of increasing representation in any field in terms of building an inclusive community. And you didn't just say build a community, you mentioned supportive community, collaborative community. So I think it's not just studying the elements and identifying them, it's actually learning how to create such communities, because we can know that we want them, but the activity of practicing and building that environment is another piece. So I think that's part of the direction. I appreciate you mentioning it.
Thank you. Yeah.
So I can just say one word about why I wrote that 1985 articles directly related to this question about lab size. So at that point, Howard Hughes was sort of a very top-down organization, and they chose individual scientists basically they wanted them to double the size of their laboratories. That was their motivation. And the whole idea was that if they had twice as much money, they'd do twice as much good work. And that had been going on for maybe 8 years or 10 years, and I knew all these people, most of them. And what I observed is they were doing less interesting things. And you could easily figure out why, because were now managing this huge enterprise. They had to write letters for recommendations for 30 people. They had no time to breathe. So these very creative people, I thought, were turned into a different kind of scientists. So that's just there are things that somebody could study if they wanted.
I think we're all sympathetic with that, Bruce, although there are many grants given to very large groups. And it would be nice to know, we'd like to have some of these people here, who would, what would Eric Lander say about large groups, for example? I think it'd be interesting. It may be that certain kinds of science benefits from that. But I actually think, I agree. I was on one of the review boards for Hughes back in those days. I'm back on one now, but after many, many years being off it. And there was one guy who came up, and he kind of didn't do too well. And but I said, it's clear that he only wants to work in a small area. If we gave him less money, they should really continue them. And they got really angry at me because they said, no, we make the decision about money. And so I think that there are people who probably can't even function in large groups. Some people who can function in large groups but maybe aren't as creative. And maybe there are circumstances where large groups are creative. And I love a study, even anecdotal or historical, that gives us a way of judging that. It would be very helpful.
So our next speaker is Shirley Tilghman. She's the incoming president of ASCB. She's professor of molecular biology at Princeton, and she recently held the position of president of that university. She's been a passionate advocate for young scientists for many years, and she recently chaired NIH's advisory committee to the director's workforce report in 2012. And of course, she's also a co-author on the PNAS piece, which you've heard all about today. And the title of her talk is Creating a Sustainable Workforce for Biomedical Science. Let's welcome Shirley.
Good afternoon, everyone, and thank you for coming to engage in this conversation. I especially want to thank Jessica Polka, who has been such a leader among the young scientists, not just within ASCB, which has been absolutely critical, but I think on a larger, more national scale. So, Jessica, thank you so much for continuing to highlight these issues. So it feels a little strange to be speaking after my partners in crime, Bruce Alberts and Marc Kirschner, because the three of us, together with Harold Varmus, as Jessica said, have spent almost 2 years now spending a fair amount of our time thinking about issues related to biomedical research. And I think I might preface my remarks by saying that I think I came to our discussions with perhaps an unusual perspective. And that is after spending the vast majority of my career embedded within the biomedical research community, I took a 12-year sabbatical where I was spending time thinking about binge drinking and football concussions and, financial aid for low-income students and really was not paying attention to what was happening in my own community. I simply didn't have the time to do it. So when I started to re-enter, I felt like one of those spacecraft from Mars coming back into our U.S. orbit. I was really, to be honest, taken aback. As I began to talk to my colleagues at Princeton, and particularly as I began talking to students at Princeton, I realized that in the 13 years basically where I had been away, the feeling in the community, the sense of forward progress, the sense of optimism, had really eroded, and it felt like a very different atmosphere from the one that I had left in 2001, which of course was in the middle of the doubling of the NIH budget, a very specific time in the history of funding for biomedical science. And it was really the result of a breakfast with Marc in Boston, sort of toward the end of my term as president, that I sort of began to realize that how serious the issues were and why it was important for those of us who cared deeply about the future of biomedical research and believed deeply in its capacity to do good, to make the world a better place, that it was our responsibility to really start thinking more concretely about the problem. And I think Marc has laid out, in my view, the most important reason why we should care about this. And that is the degree to which the current circumstances are undermining our ability to do our very, very best science. In part because we don't have the time to think deeply about our science, and in part because we are discouraging the best and the brightest of the next generation from entertaining the possibility of careers in science. And if you combine those two things in one unhealthy package, I think you do have a recipe that perhaps, for example, I think one of the criticisms the four of us have faced is, gee, science seems so exciting right now. Great science is being done. What's the problem? Why, I don't understand why you think there is a problem. And I think our answer to that is that the ground conditions that we're laying out for this next generation, and the ground conditions that we've created for our own generation, are not conditions that promote the very, very best science. And to a certain extent, of course, the four of us are susceptible to nostalgia. You know, we grew up, the four of us, in the golden age. What's, at least now, looking back on it, seems to me like the golden age, where we did have time to think about our science, where we believed that if we did good science, we would be rewarded. We would get grants. We would get jobs. We would get our papers published, and in a broad array of journals, by the way. And so, but I don't believe that fundamentally this is nostalgia speaking. I think we've tried to take a hard, cold look at what is happening, and to the greatest extent that we can possibly do it, do it without rose-colored glasses, looking backwards. So, if I had to use one sentence to describe what I think is the core of the problems that result in the phenotype that Marc just described. And I apologize to Bruce because I came in at the very end of his talk, although I know it was brilliant. Is that we have too many people chasing too little money in academic science today. That, if you can trace virtually everything, every phenotype of the low morale back to that problem. So, as a scientist, you can say, okay, if that's really it in a nutshell, what are our options? One option for the optimist is that we can do what we have done for, a couple of generations, which is we spend a lot of time in Washington lobbying for money, more money, making the argument that if we just have more money, everything will be better. And no one doubts two things. One is more money would make things feel better. That's almost an obvious point. But the problem is that I don't know anybody in Washington, and we've got Jon Lorsch here sitting in the second row who can probably be more informative about this than anyone else in the room, who thinks that is going to be the solution. Furthermore, one of the questions that came up a few minutes ago was the question of whether there are structural problems in the system that more money simply cannot fix. And I'm going to argue that that is the case. So even if you believe the more money would make things better, it won't fix the problem. And so we have to come face to face with the fact that we have, right now, too many people in the system competing in a hyper-competitive environment for a finite and not likely to significantly grow pot of money. So if you believe that's the problem, you now have to say, okay, where in the pipeline can we actually make a difference? And so I'm going to just kind of take you through career stages and not give you solutions because, frankly, one of the really challenging things here is that I don't think any of us have a silver bullet. None of us knows that there's one thing we can do, one lever to pull, and all will be well. This is a highly complex organism, ecosystem that we're dealing with, and there is no easy fix. So I want to begin with undergraduates because that's who I spend a lot of my time with. And I spend my time with a lot of very, very smart undergraduates, many of whom are very excited about the future of biology and are, the idea of spending a life making discoveries in molecular biology or genetics or neuroscience or bioengineering, for them just seems like an extraordinarily exciting thing. But by the time these students get to senior year, it is the heaviest lift of all to persuade them to think about going to graduate school. Partly because they are living in the environment of our research labs. They can see the challenges that their PI is facing, their graduate student and postdoc colleagues are facing. And so one of the reasons I'm most concerned about this problem is the challenge I've been having in talking to the ones who I believe not only should go to graduate school, but would flourish in graduate school and flourish later on, the challenge I have of persuading them to do it. Now, those students are very well aware of the situation. And so when they do decide to make the decision that they want to enter the pipeline and go to graduate school, for the most part, they are pretty well informed. But in my view, they're not well informed enough. And after literally 20 years, Jon, I am speaking to you, my friend. After 20 years of sitting on various reports, making the recommendation that a requirement for every graduate program in this country that benefits from federal funds, either through training grants, which you know I'm a big supporter of, or because they are supported on federal research grants, must be required to post on their website the career outcomes of their graduate students. I mean, to me, this is about as low-lying fruit as exists in this policy space. So you want to know. What would you want to know as a beginning graduate student? There's probably some here in the audience. You would want to know, well, how long did it take students to get a degree in this program? You would want to know, did they finish the degree at all? Did they actually get through the program? You would want to know what postdoctoral positions did they take? And I don't mean that narrowly in terms of postdoctoral positions. I mean, what did they do after graduate school? And I'd like to know what they're doing 15 years after graduate school. And I would like to know that because those numbers, although retrospective, to be sure, will tell prospective graduate students, you know, this program prepares students in these areas, and I might be interested in a career in this area. So I'm begging the NIH, on my hands and knees if I have to. As a minimum, let's get that information up on everybody's website so students can make informed decisions. So once you're in graduate school, I just met on Thursday with someone who's running a graduate school, graduate program out on the West Coast, who told me that she gathered together the first-year students and told them something that she got off the ASCB career path figure. Jessica, I don't know if you showed it earlier, the famous figure that shows that there are no alternative careers for PhDs in biomedical science anymore. All careers are alternative careers, especially faculty careers, which are now roughly 15% of graduate students today are moving on to academic faculty jobs. That's something that you should know on day one, because the only way I think as a graduate student that you can navigate the current system is deliberately, planning ahead, knowing what your options are, developing which of those paths is the one that you think is most fits your interests and your skills, and then pursuing it pretty single-mindedly. That's the way to have a successful graduate career. But you can't know that if you're going into a graduate program that is still in what I consider the dark ages and still leaving students with the perception that all of them will ultimately receive faculty jobs. That's just simply is wrong. It's not the case. But I think it's more, we need to do more than just tell them that. We have to give them opportunities to explore those options. And that's why those BEST grants that were mentioned a few minutes ago, that Connie, I think, mentioned, are so important because they're catalyzing departments thinking in how to really turn graduate education back into education and away from a work program. Giving them opportunities to explore the many options. Now, this is assuming, of course, that we continue to admit graduate students into graduate programs the way we currently are now, which is in a very distributed system. You know, every university basically is making its own decisions about how many graduate students to admit, and that is not helping with, remember, the original problem. The original problem is to right-size the entire enterprise. And I think there are two ways to think about this. And many of my colleagues who've responded to the PNAS article believe that we should not be right-sizing at graduate school, that there are many benefits to having a PhD in molecular biology. It teaches, you know, many of the qualities that you'll use in your career no matter what your career is, as long as you know in advance that that is the case. And furthermore, many of us who've done graduate admission believe that it's very hard at the time of graduate admission to predict who's going to be really a successful scientist. And so kind of narrowing the pipeline at the entry to graduate school, many argue, is the wrong place to do it. And I think there are good arguments for that position. I think there are some pretty compelling arguments to ask Jon Lorsch to increase the number of training grants around the country as a way, in fact, to better control the numbers of entries into the graduate programs in the United States. But I think this is a debate we should have as a community, because it's not clear to me which, in fact, is the best way to proceed. But if we are going to let those numbers essentially grow uncontrolled the way, or continue to be the numbers that we see, then we've got to really take seriously what happens after the PhD. Because we cannot be sending 75% of those individuals on to postdocs right now. We can't afford it, frankly. We simply can't afford it. So that's why these BEST grants are so important, because they're allowing graduate students to distribute after graduation between those positions that do not require postdocs. They should not be doing postdocs. It's not a good use of their time. And those who really want to have bench research careers, and for those individuals, postdocs are absolutely critical. So I think there are really good and compelling arguments that some of the filtering should be happening at the end of graduate school, where we reduce the number of individuals who are going on to postdoctoral fellows in a positive way by sending those who don't want to do research on to other things. And there is a negative way of doing it. And I know that there is likely to be a very strong recommendation coming out of the NRC in a few days, at least I hope it's going to be in a few days, that one way to narrow the pool of postdoctoral fellows is to pay them more. Basically, make postdoctoral fellows more expensive. If you make them more expensive, we can afford fewer of them, and inevitably the net consequence is that there will be fewer postdoctoral fellows. I've heard arguments in favor of this, and we're going to read about them in this NRC report that Greg Petsko has chaired. And I've heard some pretty compelling arguments from people I very much respect that this is exactly the wrong way to go. Again, we need to have a debate about this. I think we have to think hard about those options and others as well. But remember, we've got to downsize. And so if we're not doing it at the graduate level, we've got to figure out how to do it at the postdoctoral level. So those are the at the postdoctoral level. And clearly, you heard from Connie, and I was so glad that Connie in her talk said this. We are not growing our faculties. And in fact, if anything, our faculties are shrinking. And they're not shrinking at places like the University of Chicago, but folks, they are shrinking in hundreds of universities and colleges around this country who are now in such financial straits that they are essentially transitioning from full-time tenure-track faculty to adjunct faculty, which are very cheap. I would argue is educationally disastrous. But this is the response to literally hundreds of colleges and universities around the country are making that transition. So we are not going to be looking at even steady state in terms of academic positions in the future. Those positions are actually going to be declining even further, which is yet another reason why those best grants can't simply concentrate on graduate students, but must focus on graduate students as well, who have to be thinking about other paths to take. The ASCB is doing, I think, some really innovative things in this area. I think the KEC program for postdocs who are interested in careers in biotechnology is one example of many programs that we should probably be catalyzing around the country that allow postdoctoral fellows to think about how to have the right set of tools so that they will be competitive for positions in industry and elsewhere. But at the end of the day, we're going to have to think about how we are going to downsize our enterprise. There is no way around this, folks. There really isn't. So the last thing I want to mention, which again has been recommended multiple times in multiple reports over the years, but is really, I think, only beneficial to science. And that is, and this comes to the structural issues that I think you were asking about in your question. We've got to start thinking about the structure of the academic lab. So my academic lab, and I'm guilty of this as anybody, was composed of 5 graduate students and 5 postdoctoral fellows and 1 permanent person, my lab manager, who basically, ran the lab, ran the technical aspects of the lab. That is the deep, fundamental structural problem that money won't solve. And that is, it's a Malthusian system. It's a system that no matter how much money there is, it's crying out for even more money, because what you are doing is the people who are conducting that research are heading toward positions where they are going to be looking to dip their fingers in the pie. And the pie, remember, is finite. So we have got to start thinking about how to encourage more permanent positions in the average biological laboratory. The NIH has been doing this for years, and Harold Varmus, who created the program, will tell you those are some of the most valued scientists at the NIH, individuals who are either master's or PhD level scientists who are actively conducting original research in those laboratories, but are not on the way to wanting to put their fingers in the pie. There have been many criticisms of this in the past. People who speak, sort of watery-eyed about how creative graduate students are and how uncreative such a person would be. People who say that have never actually had a first-year graduate student in their lab. I don't think I am, not exaggerating, nor have they had one of these people in their lab. And we're not suggesting in this recommendation that you move from 9-1 to 9-1 in the other direction. We're looking for balance. We're looking for balance so that the amount of work can get done, and yet it's being done by people who are more stably part of that laboratory. So I'm going to stop there. I know we have several other speakers, and I know that the message that I'm delivering is not one that is generally easy to swallow. But again, I think if you keep focusing in on the things that Marc talked about what we're trying to do is create an environment where we can all do our very, very best science, then we all have a stake in solving this problem. Thank you. Yeah.
Just a very quick comment. I'm Lenny from Zappi Lab. Very quick comment about the golden age of biology. So I went into graduate school in 2003, switching from math and computer science into biology, precisely because I felt that this is the golden age of biology. And even though I left academia and I wrote Goodbye Academia that went super viral, I still feel that scientifically this today is the golden age of biology. And particularly what is heartbreaking is that we're at a point where the technology, where the science, where what we're learning is in the golden age, but the infrastructure is such that when any student who looks at the statistics would be depressed and probably wouldn't choose, the best ones would not choose to go into PhD programs. And we have to solve that so that we can have the golden age.
Thank you for that comment, because I've been giving talks about this around the country that I call the best of times, the worst of times. And I start out with the best of times. That's how it feels to me. That's the other half of what I felt when I came back in, which is, where was CRISPR when I needed her? I mean, all the things that are possible now that I could have only dreamt about, it seems incredibly exciting. So I thank you for making that point. I think it's a really important one. Yeah.
So very nice comments, and I've thought about these ideas that you present and trying to put them in context or juxtaposition with this idea of trying to diversify the faculty. And that coming in contact with the fact that there's no mandatory retirement. Right? So we have these three things happening: reduced funding, no mandatory retirement, but yet we have a pool of a more diverse America that need to be represented, and there's no space.
Yeah.
I'm wondering if you can comment on that.
I think I'm now going to put my university president hat back on and tell you the worst thing that ever happened to universities was ending mandatory retirement, because it's created an aging of the workforce, not just in science, believe me, but across all of the disciplines, that is very, very hard for universities to manage now. And I completely agree that it makes it much more challenging for us to diversify our faculty when there are so few entry positions coming open.
Okay. Hey, my name is Pinar. I'm at Dartmouth. Well, I just finished there. But anyway, I was just wondering if you could comment on, so, you stated that graduate students on day one should realize that, becoming a PI is essentially now an alternative career and that sort of thing, and to be aware of what your options are as you begin. But I guess my question is, most of us are being trained by these PIs who have gone through, that system, and so these are the guys who are mentoring us, and they don't really, what is their role now supposed to be?
Yeah.
They can't really, if they're going to encourage us to do these different things, they're not very well trained for that, so, how does that fit in?
I think there are two things that get in the way. You've named one of them. Which is that the faculty, almost by definition, have only known one career path, and not all of them have sort of fingers in other worlds that would give them opportunities to really be effective mentors. The other, which is one of the reasons why I've very much supported the expansion of training grants as the right mechanism for supporting graduate students, is that many graduate students, of course, are being employed by their mentor on their research grant. And so there is no financial incentive whatsoever for them to give you time, say, to do a 3-month internship in the biotech industry. In fact, it's harmful to your mentor in that sense if you're off doing that externship when you should be, working on that grant. And so these BEST grants, which really grew out of the workforce report that we did at the NIH, are a way for universities to start thinking about how you could build really effective graduate education designed to help students find their way. And there aren't many of them right now. I wish there were many more of them. But I think they'll be catalytic. I think they're going to learn how to do this, and as they learn how to do it, there will be opportunities for other universities. But right now, I agree that it's problematic for a graduate student. Yeah, do you want to?
One more question. Angela Wenninger-Ness from the University of New Mexico. I would like to follow up on a few of the points that were heard, stated, but to crystallize it. The message here is very negative for the young people and for diversity in the room. And I really think that as a scientific community, we need to think about the other end of the spectrum. And we've heard about programs for sunsetting investigators. There are institutions who are creating academies for their senior faculty so that there are opportunities at the end of the careers that don't mean holding on to grants and holding on to positions near the end. Yeah. I am a training grant director, and until very recently, these best grants and so on, there alternative careers, which many students really want to pursue, were not valued by our community as viable endpoints. So I think you didn't touch on all those things. I think those are critical to reforming our system.
I completely agree with you, and thank you for bringing them up.
Thanks, Shirley. Our next speaker is Kenneth Gibbs. He's a postdoc in DC, and previously he was a AAAS Science and Technology Policy Fellow at the National Science Foundation. He's also on the board of directors of the National Postdoc Association, which is an organization doing amazing work to bring together postdocs and advocate for their interests. So the title of his talk today is Biomedical Ph.D. Career Development Trends, Implications for Workforce Development and Diversity. Let's welcome Kenneth.
Let's see. Sorry. Yay. So first, thank you to the organizers for inviting me. When I saw the list of people who were on here, I was shocked that I was one of them. So this is awesome. It's great to be talking about this. And so I tweet a fair amount. Now, if you quote me at STEM PhD Careers. But one of the commenters said, "Preach it, Sister Shirley," from my last set of tweets. So I'm going to grab this bottle of water and then. So my background is as a PhD immunologist. I did that at Stanford. I was a cell signaling biologist, so I think about upstream, downstream pretty frequently, and that was helpful in the policy world. And so I've been doing some data to figure out what's happening to all of us, since there's not a lot of data out there. So we all know, and you're here and you believe, that the highly trained and diverse scientific workforce is key for advancement. And I give this talk frequently, but this is a quote from the NIH report, which I find quite helpful. Successful biomedical research relies on this continued supply of highly trained talent. So we need scientists. Scientists do science, right? At the same time, the director and principal deputy of NIH said that the mission can only be achieved if we get the best and brightest from all these different backgrounds. And the kind of continued woeful underrepresentation leads to the inescapable conclusion that we're missing critical contributors from our talent pool. So just to put some numbers on this, in the biomedical scientists from underrepresented minority backgrounds, so that's Black, Hispanic, Native American, and other underrepresented minority backgrounds, are 10 to 13% of PhDs, depending on who you're counting and what disciplines you count. But the National Research Council said they were 2% of basic science tenure and tenure-track faculty at U.S. medical schools, a number unchanged since 1980. And women receive 52% of PhDs, but still are hired at about 33 to 35%, right? And so we have a pool of talent that is not being reflected in the faculty careers. Now, at the same time, we have these other things, right? There's long training, earnings are poor, and so it makes careers in biomedicine, even though we're in this golden age, kind of challenging. And there were pretty well-known reports from Cynthia Furman at UCSF and Sauerman and Roach nationally showing that as PhD training progresses, fewer PhDs reported a desire to pursue a career as a tenure-track investigator. And so putting all this together, my colleague Kim Griffin and I have been studying for the last few years this idea of really what's the process of career interest formation for recent biomedical science PhD graduates, with a specific but not exclusive focus on faculty careers, because again, unless something changes much more broadly, most federally funded biomedical research will happen in an academic institution. And And by definition, a PhD recipient has navigated any barrier to access and persistence. So from my time as a policy fellow at NSF, there's program after program to get more women and girls and minorities into science, overcome barriers. I fully support these things. What happens when you're at the kind of end of the pipeline, so to speak? And then to what extent does this process differ based on social identity, specifically race, ethnicity, and gender? Because I don't presuppose that because you have disparate outcomes, all the mediating factors are distinct. There could be different impacts of similar factors, or there could be different things happening. So I'll tell you about 2 studies we've done. This one is really quick. I'll speak about briefly. We published last year in Life Science Education called "What Do I Want to Be with My PhD?" And so I jokingly say this is my own catharsis on my own career. But we did a focus group study where we talked to 38 recent graduates about how they thought about their careers. And so this actually provided some empirical evidence to the idea that the structural dynamics that we're seeing in biomedicine are influencing career decision making. So, and importantly, because we talk about the best and brightest, which is important, even though it's not necessarily always well defined. But objective performance wasn't the thing that distinguished those who went on to academic careers versus those who didn't want to pursue academic careers, right? So in both groups, you had people publishing in Cell Science and Nature and the small journals. And so what we saw were personal values and structural dynamics were shaping career interests. And I can talk much more about this. Check the paper out. I reread it this morning to make sure I remember what was in there, and I'm happy to talk more about that. But as a lab scientist by training, I was like, did I just find 38 cranky people, or is there something more broad that's happening? And so my colleague Kim and I did a survey online in the fall of 2012 where we recruited using LinkedIn, Twitter, as well as some of the infrastructure that's been set up by NIH to promote diversity, so conferences like SACNAS and ABRCAMS, and societies like the National Postdoctoral Association, to really get the word out, say, we want to understand from your perspective what is happening in your career. And so from that, we got 1,500 U.S. citizens and permanent residents who completed their PhDs between 2007 and 12. So that's about 5% of all biomedical PhDs. And I limited analysis to U.S. citizens and permanent residents just because I think there's some fundamentally distinct issues, particularly visas, that shape the career determinants for international scholars, which I think is really important and hasn't necessarily been addressed explicitly in this talk yet. And so these folks represent the disciplines you'd expect. Very, very many cellular molecular biologists, neuroscientists, and microbiologists and immunologists, as well as other parts of the biomedical enterprise. And as you'd expect, you have a lot of postdocs, right? Which, again, if you PubMed for postdoc, you see lots of opinion papers. You don't see very much empirical evidence. And so some of the people have moved on to faculty careers and some had not. And so our survey, and this will be the last sort of setup slide, and then we'll get to data, we looked at career goals and knowledge, and we looked at career pathway interests, and we conceptualized it, again, borrowing from the Cynthia Furman framework, the idea of faculty careers at a research-intensive university, faculty careers at a teaching-intensive university, research careers outside of academia, be them in industry, pharmaceutical, biotech, or government, and then careers outside of research broadly. And I always make the point there's no value judgment on any of these career pathways. It's just the 4 ways that we thought about conceptualizing it. And we also looked at graduate and postdoctoral training experiences and career development. And so we asked folks, we did a cross-sectional retrospective study, and so we asked folks to say, where were you on these career pathways, particularly at PhD entry, PhD completion, and where are you currently now that you're in your postdoc or you've moved on to your career? And so if we focus on the postdocs just for a minute, from our previous paper, we saw that many pursued PhDs without a clear career goal. There was a love of science that drew them, but that love of science wasn't coupled with, I want to do X career. And if there was a default, there would be an academic career, but that was only because that's the only thing they typically knew. And so we asked these folks, did you have a clear career goal at PhD entry, completion, and currently? And so of these postdocs, you'll see that about 60% of them said they had a clear goal at entry. And the percentage who actually agreed with the idea that I had a clear goal went down over time by 10 percentage points. This is a quantitative, not a qualitative study. We're doing interviews to figure out why this is happening. But I think it's noteworthy that on average, these people had 8 years of training, 6 years in their PhD and 2 years in a postdoc. And so they weren't even as clear as when they started. They were less clear on average. You also asked people, were they knowledgeable about the various career options available to a PhD person in my discipline? So when they started, only 26% of people said, yes, I did have knowledge about the things I could be with a PhD. And that number increased through time. And so I always like to say the clarity that people feel early is, I think, born out of ignorance, not out of conviction. Or it's definitely not being born out of a wealth of information, at least in their own eyes. And so this data largely confirms what's been seen in other studies. And so again, looking at those 4 career pathways, we ask at PhD entry and completion, what's your level of interest on a 5-point scale in a faculty career at a research-intensive university? So that goes down significantly. Also at a teaching-intensive university, pretty stable for research careers outside of academia, and a big jump in interest for careers outside of research. Right? So this largely mirrors where we've been. So the conversation from Cynthia Furman, Sauerman, and Roach, this largely mirrors that data. So the next analytic lens, we said, okay, is this the same or is it different across lines of race, ethnicity, and gender? And so what we have here are men in the blue and red, and then women in the green and purple. And so we have men from well-represented backgrounds, and that is just looking at the representation of different racial ethnic backgrounds in the scientific workforce. So that would be white and Asian. Men from underrepresented backgrounds. Women from well-represented backgrounds and women from underrepresented backgrounds. And just as a note, this 276 scientists from underrepresented backgrounds represents 10% of the underrepresented pool in this time window. And it's the largest sample since Sigma Chi did their postdoc study a decade ago. So we have numbers, even though the underrepresented men are sometimes underpowered, we have numbers to actually begin to do comparisons. And I always like to say the most frequent reason that folks say that there isn't diversity in faculties is, oh, we can't find them. And I'm like, I say frequently, well, I found 300 of them with the internet in 3 months. So I think we need to think about how we're looking to make sure we're cultivating talent from all sources. Okay, now going back to that pool, to the career pathway interest, we see for faculty at research-intensive universities, I'll try to step over here, see if the pointer helped me. So at PhD entry, we see, and all these little marks on top are just multiple comparison corrections. And so we see men, on average, reported higher interest than women. Underrepresented women reported the lowest level of interest. And we saw that again at PhD completion. So we see this difference in the level of interest for faculty careers, particularly at research-intensive universities. You don't see that by race, ethnicity, and gender if you look at faculty careers at teaching-intensive universities or research careers outside of academia. So it's not all faculty careers or all research careers where we're seeing these differences. It's specifically for faculty careers at research-intensive universities, where places like NIH fund federal research. If we look at careers outside of research, we see that at entry, all groups reported low levels of interest, and all groups showed increases, but the increase was greater for women from underrepresented minority backgrounds. So these are group level averages, and we know that group averages can be skewed by outliers. So we said, okay, we have each person's data at completion and at entry. So let's see, like, what's your individual delta? So we said, what was the paired difference between completion and entry, where the maximum unit is 4, and then aggregated that by demographics. And so again, you'll see here that all groups, including the very well-represented men, so because most faculty are made of white and Asian men, predominantly, you still see on average a decrease there. The decrease is larger for everybody else. And if you do all the different comparisons, then this is statistically larger than that. But again, there's a general decrease that's intensified, particularly that we see in underrepresented women. Again, you don't see those differences for faculty at teaching-intensive university or research careers outside of academia. What's happening is happening to everybody equally. And for research careers outside of research, you see big increase, and then that increase is basically double for underrepresented women, which they traverse a third of the scale, just to put that in context. Okay, so we have these interests, these data. So we also wanted to ask about graduate training experiences. And so we conceptualized this idea of belonging. There's a lot of social science literature that belonging matters. And so we conceptualized that both academically, so sort of did you belong to the intellectual community, the scientific community of your graduate school research group, department, and postdoctoral research group, as well as socially. So happy to report that as we look at the level of the research group, both in grad school and postdoc, we don't see differences in the percentage of scientists from either background reporting that they belong, right? And so the light gray is agree, the black is disagree. If we look socially, though, you see that the percentage of particularly underrepresented women reporting that they belong socially in their graduate school labs or departments trails everybody else by about 15 to 20 percentage points. And so, again, and it's not that it's all bad, right? At least half of them say they belong, but it's less than everybody. It's trailing, so something's happening in environments. And I note that when you look in the postdoc, and we asked about 7 questions for postdocs, so we don't ever see differences in these sort of quality of training experiences among postdocs. So that's one point to look at. We also asked about, advisors, mentoring matters, right? The NIH has just put out a big mentoring program to help increase diversity. And so we say, does your advisor care? Are they invested in your career advancement? So again, we don't see differences by race, ethnicity, and gender. 75% of all people, no matter who you are, say, yeah, my grad advisor and my postdoc advisor is invested in my career. Did you receive equal support for the pursuit of academic and non-academic careers from your graduate advisor, graduate department, and postdoctoral advisor. So from your grad advisor and postdoc advisor, it's pretty much a 50-50 proposition. 50% of people say yes, and then 50% of people either hedge or say, no, I actually disagree. But from your graduate department, which are made of all these graduate advisors, only 30% of people say, yes, I got support. And so I don't know if this is the idea that I love my congressman, I hate Congress, my advisor's good, but all these other people are bad. But this speaks to the idea that trainees aren't feeling well supported for the pursuit of all careers in their academic environments, even though, as has been noted repeatedly, 90% of folks are going to be in careers outside of academia. And then if we ask, were you offered structured opportunities to explore a variety of career pathways, both academic and non-academic? Strong and uniform disagreement. 55% of people said no from their grad departments, the departments that admit them, educate them, make sure they get all their degree requirements. 55% of people say no. But interestingly, 2/3 of the folks said yes, they were getting it from their postdoctoral institutions, which goes along with some of the things that we've been talking about. And again, this could be a function of sampling through NPA, and maybe those people have better treatment. But again, these are all data points. So then we get to this big question. So we have all these data points flying. What explains career interest at PhD completion? Because your interest when you complete your PhD largely sets the track that you're going to go after that. And so we use what is a multiple logistic regression. And so you have a dichotomous outcome. So say, are you a high interest person or not? What statistically accounts for that? And high interest was, did you say 4 or 5 on the career pathway when you finished your PhD? So you're either 4 or 5 or not. And we controlled for all this stuff. So what was your interest when you started? What were your intentions when you started? What's your confidence in your research ability? And then objectively, how many first author papers did you publish? So we had all these people's names and contact information, so we looked them all up in Scopus. And then did you go to a top 50 institution or not? And then, again, all these grad training variables. So when you control for all these things, including first author publication rate, so we're controlling for productivity, you see that when people complete their PhD, relative to a well-represented man, all other groups were statistically significantly less likely to say that, yes, I want to pursue this career at PhD completion. So again, these are point estimates and 95% confidence intervals. So on average, well-represented women were 36% less likely, underrepresented men were 40% less likely, and underrepresented women were 55% less likely than a similarly situated, well-represented man to say that I want to pursue this career at PhD completion. So something is happening in graduate school that, and again, this gets to the idea of maybe disparate impacts of systemic issues, right? Because we control for many of the things that we think matter, and you're still seeing these disparate outcomes. And just one note, the only other thing that had a negative correlation besides race or gender was doing a PhD at a top 50 institution. So, which one of the reviewers was completely incredulous about that being the case, but it was. It basically makes you a minority man, same kind of multiplicative effect. And so, again, you don't see that difference for faculty at teaching intensive universities or research careers outside of academia. And again, if you look for careers outside of research, when you control for everything, including productivity, underrepresented women were still saying that they were twice as likely as everybody else to say, I want to do that career when I finish my PhD. And so just thinking about all this together, we, of course, know there's this altered landscape for PhDs and postdocs. And PhDs enter graduate training with really poor knowledge about their career options. On top of that, few report structured career development in their graduate training, but most reported that they got it in their postdocs. And postdocs reported significantly less clarity than the one they had at PhD entry. And so, repeating what we've seen earlier, there's a general trend away from academic careers, particularly those at research-intensive universities, and a trend toward careers outside of research. Those career trends were intensified, specifically in underrepresented women. And then you see these disparate interest patterns at PhD completion, by social identity, race, ethnicity, and gender, when you control for the things that we think and know matter, including productivity. I just want to make that point. We control for how much they've published. So what we're doing now are in-depth interviews to understand the mechanism of career formation and choice just generally. And I always say, if you ever see an email from us, please reply. It's always helpful. Don't just be angry. Contribute to studies. We can make data, and through data, you can make change. And so just some policy implications, because I was a policy guy. We, of course, need to improve career preparation and data on career outcomes. And I had that before. Sister Shirley said that. And I think as we think about diversity or representation, we frequently conflate the concepts of retention, persistence, and degree attainment with career choice and workforce development. They're different things, right? Degree attainment is necessary. It's not sufficient. And so thinking about, again, things that necessary but not sufficient. I think the pipeline metaphor actually hinders our efforts because pipelines are linear. The only way you get more out of a pipeline is to push more people in the beginning. We already have a super saturated system. I always think, like, what's the shearing forces inside the pipe that people are experiencing? Kind of bumping up molecule to molecule. And I think we got to combine student-centered efforts with institutional and systemic transformation and think about what are the reward and evaluation structures, again, in departments, institutions, and funding agencies, and thinking about are they attractive and accessible to scientists from a lot of backgrounds. And so to a point that was made earlier about I think there are good things about trying to push the pathway forward. I think there also has to be the idea of making sure that if we put in hard and fast limits, 3 years, 5 years, or whatever, the pathway to career also traverses the pathway of, or the time of family formation and child rearing. And so you want to make sure that we have pathways if a woman chooses to have a family, that she still has a pathway back onto biomedicine if she needs to take some time off for that. And again, we just need to make sure we're thinking about these things and not putting hard and fast deadlines which traverse when family formation is happening. And I also say, how do we approach broadening participation explicitly but not separately? And by that I mean, I've been in D.C. for a few years, so I get all these policy reports. And so there's rising above the gathering storm. We have a national STEM crisis, which had no mention of diversity, very little mention. And then the national academies had the Beyond Bias and Barriers, so the Women's Report. In 2011, they had the Minority Report. In 2013, they had the Minority Women's Report. NIH itself had the Workforce and Workforce Diversity Reports. And I think it's important to be able to find information, but there are interlocking issues, and so we need to make sure we talk about them together, because I am both all times black and an early career scientist. So, and we also need non-biased selection processes. So Donna Ginther's work, Joe Handelsman's work shows that there are evaluated biases. And thinking about career pathways. And so these are my final two pieces, then I'll go. So if we talk pipeline, this is of course not what happens, but I think it's in the minds of many. You just pursue a PhD and then magically out pops the faculty sometime later. And I think been thinking about this in terms of decision points and training pathways. So again, we have the 6 years of graduate training experience. Then after that, you decide what you do about a postdoc. If you choose no, it's a completely good decision. You can still join the National Postdoc Association. But you're typically channeled toward a career outside of research based on how the structures that we have now. If you do a postdoc, or a couple postdocs, you still have to make a decision about what to do afterwards. And then there are all these different career pathways you can think about. And so in this model I put in life science education last year. And so I've been thinking more ecologically. I spent some time in public health world. They have lots of models like this. And so we spend a lot of time on individuals, and we got to think about sort of what's happening at all these levels and how they're influencing each other. So again, research groups, departments, institutions, funding agencies, and how do these interplays with each other, as well as research enterprise dynamics which societies can move forward. Thank you for listening to me. I want to acknowledge quickly my colleague Kim Griffin, who's an education professor at Maryland. We've done all this work collaboratively. I didn't go from lab science to education by myself. And that's my contact. And so I want to point out that a lot of this work is going to be out on Wednesday in PLOS One. And so check it out there. And if you are still trying to get your head around why this diversity thing might matter, I wrote a piece on that for Scientific American in September, so you can check that out. And if you want to hear even more about this, I have a poster on Monday at 3, P791. So come check me out. Thank you. Did I overwhelm you?
Okay, well,
sounds good.
Let's then thank
Yep.
one more time. It's a great treat to have our final speaker here. Jon Lorsch is Director of the National Institute of General Medical Sciences at the NIH. So he oversees, I think it's about, is it 4,500 grants? Is that right?
A little less than that.
Okay.
Now.
All right. Well, which supports basic research and also conducts programs designed to enhance diversity of the biomedical research workforce. And the title of his talk today is Current Events at NIGMS.
Thank you, Jessica. Thanks for inviting me. I actually changed the title. I'm here to talk about how we might fix the system. We've had a series of great talks about problems in the system, and I really agree with most of what was said, if not everything that was said. what I spend my days doing is thinking about these problems, the ones that we've just heard about. So here's examples of many of the very difficult problems that we at NIGMS and at NIH think about all day long, and I won't go through all of them, but if you look through them, you can see the problems that we were just talking about are mostly, if not all, represented here. But what occurred to me when I first started this job about a year and a half or so ago was that at the center of all these really hard problems, there is one hard problem to rule them all, so to speak. A hard problem that really affects all of these other problems in various ways. And if we can't get a handle on this core central problem, it's going to be very difficult to fix all these other difficult and pressing problems. And that core problem that affects all these other problems is how we fund biomedical research. As many of you know, the way we fund research in this country is on a project-based model. So we ask investigators to say, in grant applications, here is a project that we're going to do in my lab, and here is what I predict 4 years in advance are the questions I'm going to be asking and all the experiments I'm going to do. Okay? There are, in my view, a number of inefficiencies in the system that are created by this project-based funding mechanism. I'm not going to enumerate all of them, but let me just give you 2 examples so you know what I'm talking about. The first is that this project-based funding model, in which we're asking people to predict in advance what they're going to be working on, is not how science actually works, right? Science, at least at its best, works by people following their noses and coming up with new ideas and approaching new opportunities as those opportunities arise. And yet, the entire construct we use for reviewing science and funding science basically ignores that, right? We're basically now trying to fit a square peg into this round funding hole. So that's one problem, is that it doesn't reflect how science is actually done, and many might say it's constraining research by forcing people to, again, predict in advance what they're going to do and then following that direction. The second problem is actually shown on this slide, if I can point to it over here, which is the distribution of funding. And Marc Kirschner alluded to that before in his talk. So because we let people subdivide the research in their lab as much as they are creative enough to do into these individual projects, and we let them get as many grants as they can get, right? And of course, as Marc said, the more money you have, the easier it is to appeal to a study section with the results you have, and therefore the easier it is to get more money. We've created a system in which there is a pretty severe disparity in funding. So to actually give you some hard numbers, if you look at the NIH funding of a single investigator, and this is true for NIGMS investigators and their whole pool of NIH funding, or an investigator in another institute or center, the top 5% have a quarter of the entire money, and the top 20% have half of it. Okay? So that's a very skewed long-tail distribution, and I would submit to you, as I'll talk about a bit more in a second, that represents a significant inefficiency in the system. And in fact, we have data that would support that that is not an efficient way to support science. So another way you could frame this question, and something I've been thinking about a lot lately, is to ask ourselves, what should the metric of our funding be? What should be a success for funding? And the way we measure our success or measure what we're doing right now is on a per grant basis. So it's the number of grants that NIH awards. But a different way of thinking about it, which I would suggest would have a lot of benefits, would be to say instead, how many investigators do we fund? And that may sound like a trivial distinction, but I think actually it's quite profound. And if we could shift the discussion and, in fact, the measurement and our approaches away from how many grants we fund to how many investigators we can support, it would create a lot of efficiencies and would simplify what we do considerably. And so just to give you an example, if we decided, NIGMS decided, here's how many investigators we think it would be optimal for us to be supporting, immediately that would allow us to make decisions about what the average grant cost should be, right? Because we know how much money we have, and now we know how many investigators we want to support. We can just divide. Of course, not every investigator is going to get the same amount, so then we could put on top of that, what should the distribution of funding look like, right? Should it be a sharp curve, or should it be something more broad? And when you're thinking about issues of size of the workforce, like Shirley Tilghman talked about, if we knew how many investigators we wanted to fund, it would immediately allow us to say things like, okay, well, how many investigators, new investigators, do we think should be coming into the system each year? Should that be a few % of the total pool? And since we're using as our unit of measure investigators, that now sets how many need to be leaving, right, each year to keep the pool the same size. Or we could alternatively modulate the size of individual budgets to make up for the people coming in, or some combination of those things, right? In the current system, the problem is we have no control over how many grants people put in, and that dramatically reduces our ability to control the size of the pool and the distribution of funding. So if we switch to this investigator as the metric of funding rather than grants, we would have much more control over this system, and we could begin to address many of these complicated issues. And so from these considerations was born a program that we're about to start to pilot. And it's called MIRA, as I'll tell you in a minute, Maximizing Investigators Research Award. The overall idea of MIRA is to fund what we're calling research programs instead of projects. So a program was defined as all of the research in somebody's lab that is relevant to the mission of NIGMS. Okay, and you could also think about it as we're funding the investigator's research. And we hope that by doing this, and I'll tell you how it's going to work in just a second, but we hope that by doing this, we can have the following benefits for the system. And the first is to increase the stability of funding in order to enhance investigators' willingness to take on ambitious scientific projects and to approach problems creatively. So this is something Bruce Alberts was stressing before. A lot of people feel, and I think there's evidence for this, that instability in the system, the constant feeling that you may fall off the funding cliff, creates conservatism, both amongst the investigators applying for grants and what research they choose to follow, and the study sections that are reviewing this research, and the funding agencies that are supporting it. So if we could increase the stability, we could begin to address some of the things Bruce was talking about. We'd also like to increase the flexibility for investigators to follow important new research directions or ideas as opportunities arise. So we don't want them to be tied to something they predicted 4 years in advance, which is obviously not how science works, as I said. Instead, we'd like to free them up that if some new opportunity arises during the course of their work, they can follow that. And a great example of this would be the discovery of RNAi, right? RNAi basically came out of a failed control experiment. Thank goodness Andy Fire had the presence of mind to let his people follow that weird result from this control experiment. And hence we know this very important and amazing pathway. But one wonders how many great discoveries have not been made because the weird result ended up falling on the wayside because the PI said, well, that's interesting, but my grant's up for renewal in 18 months and you really got to get back to the specific aims of the grant or it's not going to be refunded. So that's a consideration. And then there's the issue of improving the distribution of funding. Among the investigators that NIGMS or NIH as a whole funds, which we think, and we have evidence to support, would increase overall scientific productivity and also increase the chances for important breakthroughs. So fundamentally, and Marc Kirschner already brought up this idea of investing in science and thinking of science as an investment, and that's the way I put it too. Fundamentally, my job is to act as an investor of the taxpayer money and to try to get the taxpayers the biggest return in terms of important science on their investment. And if you think about it that way, if you're an investor and you invest just in the blue chip stocks, you're not going to get the biggest yield, right? You're going to get a much better yield as an investor by having a large, distributed, and diverse scientific portfolio. It's a principle of investment. It's a principle of supporting research as well. Now, part of the reason for that comes from the fact that we really can't predict in advance where the next great discoveries are going to come from. And so by supporting a diverse, broad portfolio, we maximize the chances that someone is going to discover something incredibly important. And we all know, if you look at the history of discoveries, they come out of all kinds of places and all kinds of labs studying all kinds of strange and interesting systems. We also hope, and this was touched on before as a problem, we hope to reduce the amount of time researchers spend writing grants, right? And allow them instead to spend more time conducting research. It is certainly not a good use of people's time to be writing grants over and over and over again, as was discussed before. Currently, the average investigator is writing 1.4 grant applications a year. That's a year, so if in a 4-year period, that's quite a number of grant applications. And as most people only have one grant, to keep one grant, they're writing 4, 5, 6 applications in that cycle. That can't be a good use of their time, and it can't be a good use of taxpayer money either. And by the same token, we want to reduce the amount of time spent reviewing grant applications. People frequently say to me, well, the review system is broken. The review system is being asked to do something it can't do. Right? There are too many good applications, and we're asking them to distinguish amongst all these great applications. The best thing we could do for peer review would be to reduce the number of applications and to increase the success rate of the applications that do come in. And so from all these considerations is born this idea for the MIRA program. The overall concept is that this would be a single grant from NIGMS to support the research of an investigator. Okay, so it'd be one grant per person from NIGMS. We're going to use an R35 mechanism, which is the same that NCI is using for its Outstanding Investigator Award. Because it would be a single grant per investigator, on average, it would be bigger, and we're going to make it longer than the current R01s. So rather than getting, say, $200,000, the average person might get $250,000, say, or maybe even if we could do it somewhat better than that. It would be 5 years instead of the current average R01 of 4 years, so you get an extra year. There'd be a range of direct costs. We put $150,000 as the low end. I think we're probably going to drop that and just say, if you want to ask for $50,000, that's fine. But the high end is going to be $750,000. And we have evidence to indicate that that is the really absolute maximum that we're getting the taxpayer significant return on investment. And in fact, most people are not operating efficiently anywhere near that range. Okay, so most people are going to be at a lower range, and it's only going to be the occasional person that would get anywhere near this. Again, to increase flexibility, we're going to not tie the grant to specific aims. In fact, we're not going to have specific aims at all. Instead, the review is really going to be based on two things. Half based on the track record of the investigator, and we actually have data that says that the one thing that does predict reasonably the future productivity of an investigator is the past productivity, so that is at least based in data. And then the overall research ideas. So again, no specific details of experiments, just what are the big questions you think you might be addressing, and what's the overall strategy you might take to address them. But you're not tied to that. If you find a weird control experiment and decide to follow it up, we want you to have the flexibility to do that. Another, I hope perhaps, innovation we're thinking of we're going to be putting into the system is that rather than having the funding decision that comes out of study section be a binary one, as it is now, we're going to ask it to be an analog, or allow it to be an analog one. Okay, so currently, if you go in with your grant renewal and the study section says, yeah, you did good stuff, and we think your ideas are pretty good, but we're only giving you a 3 or 3.5, whatever it ends up being, you're not going to get funded, right? Your grant is over. Even though they said you were good, your grant is over. In this new system, we would be able to, instead of just ending your grant, modulate it. So if you came in, your previous grant period was $500,000 in direct cost, study section said, I don't think based on the amount of money you had, and to get to Bruce's point, we will actually tell the study sections how much money the investigators have so they can basically be dividing by dollars and calculating a specific activity. if they say, well, you did well, but not up to that $500,000 mark, we can modulate the budget downward for the next period rather than simply cutting them off. Okay? And that creates a very large stability in the system. So in addition to the extra year, there's now this removal of the sudden death clause, which is what's in the current system. Now, I'm determined to let new investigators into the system. There's been a lot of controversy about whether we should do that or not, but we are going to do it. But we do recognize that we don't want to compare apples to oranges. And so we are going to have separate review panels for new investigators and the established investigators. And we are also going to have separate criteria for reviewing the new investigators and the established investigators. So my light is blinking. I'll try to come to a close here in a minute. But it's useful, I think, frequently to describe things by what they are not. And I'm just going to tell you two things that MIRA is not. So MIRA is not targeted specifically at high risk, high potential reward research. This is not another pioneer or new innovator award. And it's not that we don't want high risk, high potential reward research. We certainly hope that this, in fact, as I said, will increase people's willingness to take on ambitious projects and to be creative. But as I think Marc Kirschner said, so much of science depends on people doing regular science and following their noses, and the sense that they're on. I don't think we should tell people that they have to continually come up with crazy ideas, right? If you're on the scent of figuring out a question, keep going. And we need that kind of science. It's also, and this is very important, not targeted specifically at a perceived highly elite group of investigators. Okay, so we are not trying to recreate HHMI, although some of the principles of the review, and the construct may sound similar. We're not trying to create a certain elite group. In fact, if this works out the way we hope it will, and we're able to open it up to everybody, it would be the primary funding mechanism that NIGMS uses to support all of the great scientists that NIGMS currently supports or could support in the future. So that's a very important point. This is not a scheme to create an elite class or to allow the rich to get even richer. It's in fact the opposite of that. So we did a lot of community outreach to get input on this program and to refine it. One of the things we did was a request for information. The results are shown here. This is 2 independent raters reading the comments and rating them positive, negative, or neither. And what you can see is that of the almost 300 responses we got, which is actually quite a lot for something like this, almost 80% were positive. So the community certainly responded that this was something they'd like to see us try as an experiment. We got a lot of very constructive feedback that allowed us to refine the idea. The top 2 concerns that came up were actually quite telling. The first is that the best funded labs will get even more money. So there was concern based on misperception that this was a scheme for the rich to get richer, which it's very much not. Okay, and I want to make that point clearly. It's really the opposite. It's a way that we hope to improve the distribution of funding and to get the taxpayers better return on their investment. The second, which is really the opposite of the first, is that the best funded labs will not get enough money. So clearly, the best funded labs were reading the questions carefully. And in fact, what we are asking is for the people at the top end to go into the system to take somewhat less money, to give it back into the system in exchange for stability, for increased flexibility, and an extra year. And so we'll see if they will. So very quickly, I'll just run through the implementation plan before I close. So we're just in the initial pilot phase, getting ready to roll this out. And I want to stress, this is the pilot phase. The goal is, if this works, to expand it and let everyone into it. But the trouble is that in order to test it and make sure it's going to work, we need a small group of people, right? We can't just open the gates and let 7,000 applications come in, which is what could happen. And everyone agrees that this is going to rise or fall based on peer review. So the key is really completely changing the peer review model, using different criteria, different approaches, and that can't be done in the same study sections that review R01s, right? So we have to get it out and do it separately. And so we need a moderate number of applications to test this concept. So in the pilot phase, we're going to limit the eligibility. We just want to make the point that this is not taking money away from R01s, because it's going to, as you'll see, be people who have R01s or would probably get R01s getting just a different kind of research grant. So the two funding opportunity announcements we're going to be releasing. The first has already been written, and we're just trying to get it cleared. The first would be for established PIs, and it would be for established PIs who already have a certain direct cost threshold from NIGMS. So they either have 2 or more NIGMS R01s, or they have a single NIGMS R01 for at least $400,000. Now that sounds like, oh, you're giving more money to the people who are wealthy, but remember, what we're actually going to be asking them to do is to take less money when they come into the system. So they're going to get a cut. Depending on how much they already have, it'll be bigger or less. But in exchange, they will get an extra year, they'll get more flexibility and more stability, because the funding decision now becomes a more analog one. We also, as I said, are determined to take applications from new investigators. Initially, we're going to limit it to ESIs, which is a more constrained pool, but we're actually, I think, going to open it to new investigators so that people who did a longer postdoc won't lose eligibility. We're going to write separate funding opportunity announcements for these two groups. We're going to have separate review panels and different review criteria. So really acknowledging we don't want to compare apples to oranges. During the pilot phase, this will be done in the NIGMS Office of Scientific Review, and we have a representative, Bob Horvitz, from that office, who has volunteered to review all the applications himself. Is that right, Bob? No? No. Sorry. But we are getting input from CSR right from the start, and actually we may have, if we're lucky, some people from CSR participating, because for this thing to expand and become this paradigm-shifting mechanism, which I hope it will be, it needs to eventually be run by CSR, because there'll be potentially 7,000 applications for it. And finally, when the established investigators would get one of these awards, it will require them to relinquish the rest of their NIGMS research funding within certain limits. So if they're doing a clinical trial or they have an SBIR grant, they can keep those, but the rest of their research funding they have to relinquish. So that's the idea. Again, it's an experiment. I think it's an experiment that has the potential to be transformative and to address many of the issues that Shirley and Marc and Bruce and others brought up. But I just want to end with one ask for all of you, which is that when we talk about all these problems, and you heard it today, much of the emphasis is put on what NIH can do. And that's not inappropriate. NIH is, the 800-pound gorilla. But the fact is that NIH, as I hope you now hear and you will continue to hear, is really focusing on potentially big changes. And we're taking very seriously all these problems and are willing to try new experiments to try to alleviate them. But we can make the biggest and potentially most forward-thinking changes you can imagine, and if the rest of the biomedical research enterprise doesn't make reciprocal changes, it won't make any difference, okay? And so at some level, are we in this situation here where we're all in the same boat, but the people who are doing fine are just happy and aren't going to change. And so I would ask you, when you go back to your institutions, whether you're a grad student or a postdoc or faculty or anything else, to start talking to your colleagues about what their responsibility and what your responsibility is to the overall ecosystem, right? Because everyone is going to have to change what they do. Bruce talked about lab size. That's a critical one, in order for us to right the ship. And it can be done. I think there's a very bright future, but everyone's going to have to get involved and be willing to make changes. So thank you very much.
I actually just had a question for Jon in relation to that talk. I was just wondering, you must know for your pilot program what percentage of women and underrepresented minorities would be eligible. And I guess what I'm wondering is it going to skew your pool?
Well, the pool of people who have multiple R01s or big R01s is skewed to begin with.
Right.
And so inherently we're starting with that set, right? And so we're certainly concerned about that. It hopefully won't get worse, but that's the starting set. One of the things we did in response to comments from on the RFI was to add in to the funding opportunity announcement specific language talking about the need for having a diverse portfolio, diverse in terms of every dimension, scientific areas, approaches, people, institutions, geography. And so we're going to be looking very carefully at that as we move forward and using it, in some ways to make decisions about what our portfolio should look like. Because of the reasons Kenny said, and he's written eloquently about this, diversity strengthens the research enterprise. So.
But you are saying that initial pilot, by definition, is going to actually...
It reflects what's there already.
Which is worse than...
So the question is, can we make it better from that starting out not great pool? The time we'll really be able to make it better is when and if we're able to open the whole thing up. Yeah.
In the early career, maybe there's, when you think about the early career phase, right. Because I think it can have you have a big pool there, so there might be potential there.
Exactly. Yeah.
So I have another question for Jon. I was wondering if there's any plans for having a mechanism to modulate the grants upwards if people are doing well in the interim?
Absolutely. Well, we've talked about in the interim, initially I think we're not going to put a supplement program or something like that in, so we'll see how it goes. But certainly when you come in for a review, so say a new investigator gets a MIRA, she does great stuff, she comes in for a review, she started out with $250,000, she can go up. Of course, again, one of the advantages of going to an investigator-based metric is that we now know for everyone who goes up, we have to have a reciprocal. Thanks.
So this is, again, in relation to Jon's talk. I guess this is more of a comment, which is related to the fact that those of us who pursue really basic science research typically only have one institute to go to, which is NIGMS. That is within reason. In other words, a lot of investigators at our institutions sort of are forced to make interesting choices in terms of how they steer the research to get it funded at other institutions. So the comment is mostly, I really like the idea of the program, but it'll be important as the program progresses to know how to, corral this to some extent to basic sciences, because I can also see a total disproportionate amount of investigators from other institutes funneling into this program, because I assume you're starting with NIGMS investigators, but later on it could be disproportionately skewed to everyone who claims to be doing basic sciences.
Yeah, that's a great point, and I think we need to be vigilant about that. The other side is also a worry that someone will get a MIRA that's going to be less than what they already have, and then they'll go to NCI and try to get 2 more R01s on top of that. And we have ways of looking at that as well, but that's also a concern.
So I guess just a follow-up point, quickly, is that if someone gets a MIRA, it'll be nice if it reflects the fact that they're really a basic science committed investigator, as opposed to a big investigator who is trying to broaden their enterprise in reverse.
Yeah.
I think this is a very exciting program, and I applaud you for, going out on a limb.
Thank you.
I would like to echo the question that was raised before in a slightly different way. That is the money that you're going to have in terms of cost savings from well-funded investigators needed to drive the program? Because if it is, then that may be actually very detrimental for women and representation, because otherwise, if it's not the driving force, you could change the invitation pool. So I guess
the money is a collateral benefit that would allow us to fund more investigators or similar number with better funding. again, the reason we have to have a constrained pool at the beginning is the review process, and that's a pilot. So if you have ideas for other groups we could open it up to in a way that's fair and legal, that would be very helpful. But the problem is that we haven't come up with any except the new investigators and this group. My goal is, I'll say up front, my goal is to expand this as fast as we can do, but it's going to require, getting the process worked out and making sure it works. We don't want to let everyone in and then discover that there's some systemic flaw in the idea. That's the other issue, right?
But you also don't want to launch it in a way that it's going to tilt
Yes.
so far the other way that it's
I
also
completely agree. I think Kenny's point about the new investigators is also, that's where we can really target building this diverse pool to start with and then expanding it outwards.
But you want to be careful because right now women really are highly representative in the ESI pool because of just how
Mhm.
graduate entries are. And so then you could have this two-tiered system again.
Yep.
So this is a question for the entire panel, and it's going back to the way this whole session was framed as far as the postdocs and the PhD students. And we heard a lot about the BEST and diversifying careers. And I was involved with UCSF as part of the BEST grant that they got. I just came from DC where I was on a diverse career panel committee for the Society for the Study of Evolution. And I am a huge advocate for the efforts to help the PhD students and postdocs find diverse careers, right, and not just be focused on the faculty. But the question for the panel is, suppose we succeed and you don't have to do a postdoc if you don't want to be a professor, right, and we've changed the pipeline. That would be a huge improvement. I suppose people who go into the PhD know exactly what the statistics are like. We have transparency, and they know that they're not going to get a faculty position, most likely, and they're prepared to go into industry or science writing, etc. So we've succeeded in not forcing people to go into postdocs. That'll be a huge achievement. But one key concern to me is for the people that want to be faculty, right? For the people that want to train the future generations of scientists, will the BEST program and will all of our efforts to diversify career options, will they solve the fact of what Shirley was talking about, that we have too many people who want to be in academia, too little funding for the people who are in the faculty positions, right? And what do we do so that all of the people who are going into the diverse careers, assuming we succeed, are trained by really the best people, right? That academia itself is attractive, that academia itself is competitive with all of those other diverse careers to attract the talent to train the people for those careers.
Well, I would say if we could get more of the best young people into being independent investigators earlier, that would make the career, that would be my aim, because we need to encourage the best people, the people who are really the most talented in doing research and most driven. You have to be driven to do this. You have to really want to spend all this time, and everybody knows that. We want to make it really possible for them to do that effectively, and so I don't think there's any danger myself if we did that of losing our best people to other careers. By the way, there's some biotech will tell you they often want people to do postdocs. It's not just going into academia to do a postdoc. So, moreover, no matter what we do, we're going to have more postdocs than we're going to have academic careers for us. So, the question is to keep the quality high.
I'll just add. So I think the University of Chicago BEST grant, it's also inclusive of the academic route. There's going to be management training, mentoring training, and so it is trying to also develop that career route. It's not trying to exclude it, but I agree. I don't think the BEST program is really going to get at that fundamental structural problem that you have mentioned and Shirley has brought up.
I will take another question from, it's really an extension of the previous Twitter question, but is there any role for funding that is not coming from government? In other words, is there some untapped capital that can be applied to fund science in the future?
So I'm a trustee of the Gordon Betty Moore Foundation, which is spending next year $110 million a year on basic research, really. Not just biology, physics, everything else. And there's a consortium of those foundations that are trying to see whether they can get more people interested in funding that kind of work. And in particular, can you get some of these very wealthy venture capitalists, young people with lots of money from God knows where, interested in adopting a scientist, for example. And this consortium has hired Mary Maxon, who's a terrific person many of you may know, who was formerly in biotech as a division leader and then went to work in Washington for PCAST. And then but anyway, she's trying to see what might be possible. But when you look at the numbers, the amount of money that we could expect to get from that source is not going to match what the federal government does. But they can spend it differently. But certainly that is an opportunity, and it's already happening. I mean, HHMI is a great example as well. I'd like to ask John, I'm just trying to think of myself. I was wondering if I could think of this. The reason why I wanted to have 2 grants, 2 R01s when I was active researcher is because the risk of losing one is such a high. So it seems to me, have you thought about how you could, have you talked to these people who have 2 R01s, or what could you do to make it attractive to them? Because it seems to me that's a very scary proposition. You only have 1 R01, and you have one chance to continue your scientific career.
Well, again, that's why we're changing the funding decision to be an analog one, right? Where the review process doesn't mean sudden death necessarily, but we can change your budget based on their review. Currently, as you say, people try to feather their grants because they're continually in danger of losing one completely. So if we go to a system where that cliff is removed, at least to a large part, I think that should be an incentive. And of course,
you could you could tell them they're going to do what the HHMI does. You stop them, but they have another year or something.
Yeah, and so we've talked about that too. When someone does get to a stage where it looks like we're going to have to end your grant, we could give you a ramp down year or 2. So that's definitely another possibility.
I think this is a great. Another reason I think this is really a good thing to try. So I've been a mentor at UCSF. Every assistant professor has to choose 2 mentors, and so I've been mentors. And I've been really astonished to see how different it is for them. The best young people coming in, they already start from the beginning to think that they need to have at least 2 different projects. I'm starting in science, and I have to do 2 different things so I can have 2 R01s, and it's not good scientifically for them to be doing that. And I think that's happening a lot.
Yeah, and of course, this gets the ecosystem again. The universities feed into this as well in all kinds of ways because what makes you successful, what makes you get tenure. It's how many grants you have. And it used to be 1, and now it's 2 or even 3.
So this may be a very naive question, but it's one I always wonder about, which is we think about postdocs in particular being able to direct their career. So the best and different training opportunities are things to give them a broader range of directions once they're leaving their current postdoc position. But I was thinking about the question of funding. So does it make, if a postdoc gets their own grant, are they then all of a sudden a PI and not a postdoc? Or are we able to do that? Or is that so transparently in place someplace where postdocs are, because different institutions have different regulations about who can actually be a PI. It's not necessarily the funding agency. It can be the research institution as a health center or as an academic location. So that's my main question. And then the other thing that I keep at least hearing people talk about is the best, of who's the best going on. And I really appreciated when somebody said, you don't know who the best is when they come in. And when you change the conditions in which scientists develop and grow, we don't even know what the best looks like yet. right? So I'm looking forward to some of the programs that we're creating because I think that'll change. But again, back to the question of for postdoc funding, being able to direct their careers and getting their own grants, like what does that look like institutionally?
Yeah, so that's a good question. And I think some of the awards that are coming out now from NIH, like there's this new Early Independence Award. It is kind of, that's like an independent postdoc. And so I think, I don't know exactly all the rationale for why those started, but, it had to do with, I think, part of it being promoting people at earlier stages of their career that are ready for that. And you're right, the university can grant PI status to postdocs for certain types of awards. And so, we probably do need to think about sort of the structure, a little bit of academia, when considering these new types of awards. It's right. And it goes back to also that issue about having more like staff scientists in the lab. Do we need to, shift our thinking that there's not just graduate student, postdoc, professor, contributing to the scientific enterprise?
I just want to, make another point that I made a little bit, but reiterate one point. I think it's important to reiterate the idea that people are non-static and contexts are non-static. And so the idea that you can prospectively know, right, like biology is fundamentally different now than it was 10 years ago. And so the things that are exciting and the opportunities that are available are different for a number of reasons, just as a discipline, right? And so it's hard to know that. And I think just one other thread that I just want to reiterate that the postdoc population is very different from the graduate student population, particularly as it relates to domestic versus international and also other levels of representation. So that's a giant thing. And I don't know that international visiting scientists have a strong political lobby, right? The way that other groups are able to, just as a whole. So I think that is maybe that structure has allowed issues in the postdoctoral community to not change as rapidly as many might have wanted, even though things have moved forward significantly. That's just one idea.
This is a question for Kenneth again. I liked your analogy of the pipeline, and I've been going around talking a lot about women in science across the country and talking about the fact that it's not a pipeline issue, how much in, how much out, but it's a leaky pipeline. It's where you come out along the pipeline. Yeah. But I really liked your shear forces within the pipeline. That was really good. Yeah. But I wonder if in thinking about these things, of that trend toward choices that people are making, if in addition to what we are doing as our own community, you or others are also thinking about the outside community. Because one thing that really struck me going around talking about issues of women in science and leaky pipeline is that it's not restricted to biomedicine. This is something that we are in our culture as a whole, listening on the radio to Diane Ream's show, about women in business, and that there are choices that are people making in society in general that are being reflected in our profession, but they are also cutting across all professions. And so I wonder to what degree those kinds of forces are being accounted for, and if people are thinking it's not just us and what we're doing, but how to broaden out that conversation.
Yeah. My thought is, I have a couple thoughts. One, when I say the shearing forces, because I actually have something coming out also on Wednesday in Scientific American, I was like, why do we need to think beyond the pipeline? Because I really don't think the metaphor helps us. I think it focuses on people and not systems. My sense is that these are... we see an intensification of forces that are broader in American work, right? And so the structure of American work has changed. So if you go to sociologically, right, there are more women in the workforce. The structure of science hasn't really changed in the last 50 years. So 50 years ago, they were men predominantly who had a large number of support, right? And I just think when we're thinking through the kind of life course perspective, right, kids matter, and I think that's the big thing that you see. And I think additionally, when we talk about community, when we talk about for women from underrepresented backgrounds, particularly, community broadens out beyond scientific community. It goes to social community, and that's something that we need to think about as well. And how can we structure what we evaluate people for so that it is attractive to a large number of people? My wife says frequently, she's like, if there's 80 hours of work for a person to do, you need to hire 2 people to do it, right? And she's a lawyer in nonprofit law, but just as an aside, one of her colleagues who was a high-powered corporate lawyer, had to recently leave that because it was untenable with her with her responsibilities as a mother, right? So people have multiple roles, and I don't think that having a strong caregiving role precludes a person from participating in science, right? And I thought, like, we've been able to get men on the moon, we've been able to do organ transplantation, and it just seems weird that we can't figure out how to get parents into science from all back, right? Like, and so it's a structure issue it is a broader structure issue that we've intensified, and I think the pressures when money is tight, then you double down on the pressures that are already there, and those structurally disproportionately impact women and scientists from underrepresented backgrounds. But they impact, as I say, it impacts the well-represented brothers too. It just hits everybody else more, is my sense.
So this is sort of a general question. It's a point of discussion. So we've been talking about how science is funded and looking at altering the relationship between the R01 and the investigator, and altering perhaps the relationship between how universities pay their faculty. But the one thing I haven't heard is the idea of indirect costs and whether that's an issue that has been discussed.
They're all looking at me. That's perennially an issue that's considered. There was an article in Nature you may have seen recently that is good in describing how incredibly complicated that issue is. Certainly if you look at it, there's a big pot of money there, and it would be appealing to take some of that and give it to investigators. But you do have to step back and think about how the U.S. supports its research institutions. So, in Europe, for instance, governments give a lot of money directly to research institutions to support them, to universities, et cetera. Here, a lot of that is coming from these indirect costs. So if you just took it away, it would be catastrophic for the infrastructure in the country. The question is, can it be made somewhat more fair? Is there places we could increase the efficiency and recoup some costs without harming the system? And can we remove perverse incentives from it? I think that's probably the biggest issue. So for instance, I'll just give you an example. In negotiating, we don't negotiate indirect costs, they're negotiated for us. But when those negotiations are done, university debt for building buildings counts in their favor. Okay, so that is an incentive to build more buildings and then fill it with people that you can't pay for. So I think that's probably the area that should be investigated. This is a bigger issue than NIH. NIH can't fix this. This has to be fixed at a higher level, and is going to, in fact, probably require Congress. Then the question is, do you want to go there?
So my question is about current postdocs. So there's a lot of things that have been discussed have been about broadening training for people who are at the student level, so that they may choose to veer away from a postdoc if it winds up being unnecessary for an alternate future career that doesn't involve academic science. But there's an enormous number of postdocs currently now in the system that, depending on how the university sees them, don't even have access to university resources for training because they're not considered students and they're not employees. And I was wondering, for those postdocs, what sorts of initiatives are on the horizon to sort of help them navigate this current landscape where it's very difficult for them to move out of that system into a faculty career or into another non-academic research career, or for many, they wind up in this sort of middle ground where they wind up as research staff or something like that. And sort of attached to that question, one of the things that was mentioned is also creating a framework within universities for staff scientist positions that do not rely on them independently applying for grants. And I came to my PhD a little bit late. Mm-hmm. I was actually one of those people in labs for a very long time. Besides wanting to establish independence and have my own research program, one of the motivators was there was no career track for me if I wanted to stay in that position. Mm-hmm. So those are the two topics that I was wondering what your views on were.
A couple of quick thoughts. One, I know they've been trying, I don't know what the evaluation is on this, but there have been moves to do professional science master's degrees, which, again, like you said, there are lots of levers, and so people have to be able to choose to hire one of those people. And so that's an institutional and personal thing. I would just say to you, recently the Office of Management and Budget and NIH put out a notice in mid-October, clarifying and Google it clarifies the dual roles, and I put it on my Twitter page too, clarifying the dual roles of trainees who are on research grants. And so they say you are both employed for doing federal work and there's a training component. Now, it's not specify what that means, but I think of it as a declaration of rights that then starts a conversation of how does that get operationalized. But that's come out from OMB, and then NIH put out a circular in the last month, right? So there is a federal recognition that there are dual roles, and it's that weird cognitive dissonance that both grad students and postdoctoral training are training, but if you're on a research grant, you're not a trainee. You're only a trainee if you're on a T or you have your F award, and so it's that weird dissonance, and that's like the legal thing back in the 70s, right? Like,
yeah, I'll just highlight. This was very important. It didn't get a lot of press, but basically what it says is that although you are paid 100% off a research grant as a postdoc or a graduate student, going and taking a course for 20% of your time is perfectly legal. Okay, and it wasn't entirely clear before, and so you could have been held hostage to that.
Well, I think that one of the things I know, because I was on a training grant for my postdoc, and so I wound up being a non-benefits eligible trainee as opposed to other postdocs at my same university who were hired as staff, and so they had access to a lot of resources that I didn't. I understand that. I think it was an unintended consequence, because I understand that the training grants were meant to sort of begin to establish your independence, that this was your training program and you weren't like a university employee that had to perhaps not follow certain things in your program that you wanted to do. Like, in other words, it didn't hold you hostage to the university. But it does wind up, for many of us, cutting us off from resources.
And one other point, and thank you for that. I would just add that the National Postdoc Association, for which I'm on the board of directors, recently put out an institutional policy report. And so if you are a member, you have access. If not, join. Institutions are members too, but it lays out for about half of the postdoc offices, I think we're able to get information about half of the offices, sort of who has what kind of benefits. So again, data are important because what gets measured gets changed. And so the data are there now nationally by both institution size and by training type. So are you an R-funded, T-funded, institutionally funded, or individually funded person? Like, we have breakdowns by that. So I think it's an important step. So I just want to reiterate that exists, and check it out from the National Postdoc Association.
So I just wanted to address the point. So I'm a PI of one of the best grants at Cornell. And so one of the things about the BEST program, and the PIs get together once a month by teleconference and meet in person once a year. But one of the issues about that is the postdocs the PIs are pushing for the postdocs to get access to all of the resources available at institution so that this issue doesn't come up. And then the second issue is institutionalizing these practices so that once these programs go away, they're only funded for 5 years, that they're now integrated into the network of both graduate student training and postdoc training, so that issues like how you're funded isn't an issue in terms of how you get support for your career.
Yeah, I was going to say, so at University of Chicago, at least, before they found out whether they were awarded the grant, they were actually, because they had, this energy had kind of started, they'd come together to put this proposal together, they were actually going to start some of the initiatives even without getting funding. So there really was a lot of enthusiasm, and, they were going to try to start fundraising, to sponsor some of these events. But then luckily we got funded. But so hopefully, after this is over, we can kind of keep these things going, because I agree, it should be institutional.
So for exposing the students and postdocs to all of the career options that exist, if the university doesn't have a good program for it, because there's only 5 or 10 BEST programs, right? The faculty have to do it. The faculty don't know how to do it. They don't know what the options are. And one of the crazy things to me about academia, in addition to all of the things we've talked about, is that we don't select people who are great mentors. We don't teach them how to mentor, and we never reward them for mentoring by tenure track decisions or funding, right? So nowhere, and how do we call our professors as students and postdocs? We call them mentors and advisors, right? Your lifetime contribution as a scientist who's leading a lab is the people you've trained, and nowhere do we teach you or reward it. And I wonder if there are any efforts, right, to improve and encourage, guide, reward, and teach the faculty to do this.
So more than 10 years ago, the Academy put out a wonderful little book called Advisor, Mentor, Teacher, Friend, something like that. Anyway, it's a little book about how to be a mentor, and it was like $1 to buy it. And the advice was to buy copies of that and put them on every professor's chair. Because what you say is true. The faculty don't know about it, but I think most faculty would like to be useful, but they don't know this stuff. But I would hope that the BEST program would develop national resources that could help people that are not in, you can't expect the faculty who've never done anything but academia to be able to be good advisors on how to get a career in biotech. So we have to do something nationally.
And I was just saying, there are some institutional efforts. So I got invited to speak at the University of Alabama, Birmingham. They have a mentoring academy for all new faculty, and I'm the keynote speaker there. So I know I know as one so I know there are institutions that do it, but again, I would reiterate there does need to be something national. I think sometimes as scientists we want to make sure we have all the data before we do anything, and it's sometimes just try and experiment and you're not ruin a person's life, but go with good intentions. And a lot of times it's just talk to them, see what they need, and figure out how to leverage the resources that you have. It doesn't have to be this giant thing, It's like you're dealing with a person, and just talk to that person who also can do science, as opposed to a science entity.
I think also postdocs can do a lot to sort of advocate for themselves on this. So there are a lot of resources through ASCB or other associations, and often, if you find you need some more support on sort of career development, I think you might be able to go to an office and be like, hey, we want to do this, we'll bring in the speakers, and you can convince them to support your efforts in doing that.
It does depend on how many resources there are at your institution. Yes. There's a paper by, I think, Stephen Lee and Rick McGee. Rick McGee at Northwestern writes a lot on training stuff, and they have a paper called Mentoring Up. So that's something that postdocs can think about. How do you help them do it? Because individual trainees also have a responsibility. Institutions have a responsibility. PIs have a responsibility. NIH has a responsibility. So do what you can do and take the agency you need. And
We'll have one last question.
So I was sitting here and listening to all this great talk, and I'm very happy that I'm here and to hear that. But one thing to summarize of everything that I've heard is that there is lots of people, that science needs lots of people, right, to work properly, because we don't know who's going to be good, who is not going to be good. And on the other spectrum is there is lots of people in science who need to do something else at the end. So how to balance those things? And I think that the idea to attract lots of people is good, but as long as you give them other opportunities, first to attract them and to tell them, look, if you are really good, you are really going to be awarded. But if you just try, you're still going to be awarded. So to give them other options that are equally valued. So and I think that sometimes, we don't do that. We just tell them, you have to be good in science, and if you are not good, sorry, you have to find a way out. And then we are coming with the best and tell them, okay, we're going to help you a little bit, so these are other things that you can do. While at the same time, I think if we would tell them, for these other things that you can do, also advertise scientists as being good in doing these other things would also be good. Instead of you have to reinvent yourself, and this whole life you were, looking at cells, and now you have to pull the kind of the skills that you have that can be reapplied to something else. So I think if they would be at least half a semester internships that would be included in postdoctoral stipends or programs where these people could actually go and do something else if they don't excel in science, would be very beneficial for these other institutions and for people, and for people not being afraid to try science. So that's all what I have to say.
I think another thing that we should all be thinking about is trying to help create new career pathways. I think that many of our postdocs would be fantastic in other parts of society where they're badly needed. And my favorite is in the central offices of school districts, which don't have generally anybody in the school district who actually is passionate about science and understands and can connect to science. And so one of the things I think that would be great to try to do is to create a new pathway that will enable selected people to go there. That's just one of many. I'm sure there are other examples, but I think that we're in a way it's a great situation for us in the sense of we have these wonderful, talented people who are passionate about science. If we could get them out in society, those who don't, this is going to be great for the society. But so we got to work hard on this.
And I'll just do one plug for the AAAS fellowship, which I did previously. You'd be astounded by how much science policy is made by 24-year-old political science majors. When you understand the inputs, the outputs make a lot of sense, right? Signal biologists think upstream, downstream, input, output. So the output of how the federal government and Congress specifically thinks about science is based on the people who are shaping those views. And no shade to 24-year-old political science majors, right? It's just there's a different worldview. I don't know that I could go and reasonably legislate their industry or prescribe what needs to happen in their industry. And I think that people in our backgrounds, whether it's Hill Days with Society, getting in there for a year or two, making it a career, it's important because it's a really important contribution. The voices aren't there. So that's another way to think about what you can do it yourself.
All right, I want to thank all of our panelists and speakers. This has been a really wonderful opportunity to continue this conversation. And I want to encourage everyone present, both here and remotely, to keep watching futureofresearch.org. Bruce, is it rescuingbiomedicalresearch.com? Is that right?
From its systematic flaws.
Systematic flaws? Okay, the website? Or
yeah, well,
okay.
We have to develop the website.
Okay, there's a web that exists. And and I hope that through the National Postdoc Association and through other venues, am I missing anything? That we can continue having these kinds of interactions. So
I think we should thank our two organizers again.
Yes, thank you, Kristin. And thank you all so much. Okay.